Sekarang sudah ada kontak center PLN 123. Bisa tambah daya, bisa pasang baru, atau ada gangguan listrik, bisa bagi kontak center PLN 123. Bisa lewat telepon, email, dan Facebook juga bisa nih. Yang paling seru lewat Twitter.
Kalau gitu, Mama bisa ngumpul di sana lebih lama lagi dong. Urusan ke PLN bisa kapan aja kan?
Kontak Center PLN 123. Kemudahan akses layanan listrik PLN. Kapan saja, di mana saja.
Kalau dipikirkan, rasa yang tumbuh ini hadir dari kebersamaanku dengannya. Rasa dekat dan peduli ada karena merasa sudah mengenal. Mengenalnya yang baik, dan memberikan keperluan dalam hidup, memberikanku segala keindahan. Bahkan mengenalnya yang sedih dan didera-derasnya perubahan bumi. Dia adalah alam. Aku menaruh kepercayaan kepadanya ketika berada di wilayahnya. Percaya bahwa sekeras apapun dia menerpa, aku yakin semua akan baik pada waktunya jika kita juga menjaganya.
Anak baru, sini. Aku mau nomor kamu now. Maksud saya nomor rekening. Memang kamu nggak mau gajian?
Belum punya.
Bikin dong now.
Zaman now, buka tabungan, tinggal scan aja. Terus, ikuti langkah-langkah gampangnya. Gak pakai download app, jadi gak boros kuota, apalagi memori.
Nomor HP kamu?
Butuh buka tabungan now.
Saatnya mandiri.
Yes, akhirnya laku juga gue. Pinjam rekening mandiri lu dong. Ada yang mau transfer ke gue nih, penting.
Now banget. Tuh.
Zaman now, buka tabungan, tinggal scan aja. Terus, ikuti langkah-langkah gampangnya. Gak pakai download app, jadi gak boros kuota, apalagi memori.
Laris manis nih online store-nya.
Kak, boleh kirim foto saya tadi?
Foto?
Butuh buka tabungan now.
Saatnya mandiri.
Dapat tuh. Tinggal satu bro, harus bayar now. Tapi pakai rekening mandiri, gua adanya cash.
Scan now aja.
Bro, scan now.
Zaman now, buka tabungan, tinggal scan aja. Terus, ikuti langkah-langkah gampangnya. Gak pakai download app, jadi gak boros kuota, apalagi memori.
Helm lu kok beda? Sengaja, beli promo dapat 2.
Butuh buka tabungan now.
Saatnya mandiri.
Daripada handphone kamu hanya diam tergeletak, kamu sudah coba belum menelpon teman lama dan menanyakan kabarnya?
Halo Jaya, lagi pusing soal toko.
Pernah nggak bantu posting dagangan baru teman kamu? Pernah coba belanja untuk mereka yang penting buat kamu? Semoga Hari Merdeka di tahun yang sulit ini bukan hanya jadi slogan semata, tapi jadi titik pengingat untuk saling membantu apa yang kita bisa untuk sesama. Kami akan selalu ada bersama kamu dan handphonemu. Sedikit di sini, sedikit di sana, sebagai satu bangsa, satu Indonesia.
Pagi, masker.
Negeri ini dianugerahi dengan kekayaan alam yang melimpah. Lautan luas merajut ribuan gugusan pulau, membentuk untayan Zamrud Khatulistiwa. Selat Malaka yang berada di beranda depan Indonesia adalah jalur pelayaran terpenting di dunia. Pelindo 1 hadir sebagai perusahaan pelabuhan utama di Selat Malaka yang merupakan perairan tersibuk di dunia dan menjadi titik penting perdagangan global. Pelindo 1 Indonesia Gateway.
Mau buka rekening tapi mager? Pakai Brimo. Buka rekening langsung dari HP. Login keseruanmu, download Brimo sekarang. Mau gampang login? Pakai Brimo. Bisa fingerprint dan Face ID. Login keseruanmu, download Brimo sekarang. Gak bawa kartu ATM? Pakai Brimo. Tarik tunai di ATM gak pakai kartu. Login keseruanmu, download Brimo sekarang. Ribet nginget nomor rekening? Pakai Brimo. Rekening bisa pakai nama alias. Login keseruanmu, download Brimo sekarang.
Kami selalu ada, satukan perbedaan dalam semangat kebangsaan. Kami selalu ada hingga pelosok Nusantara. Hadirkan kemudahan menjadi nyata. Kami selalu ada, wujudkan mimpi. Bagi seluruh anak negeri. Kami selalu ada, dekatkan hati, jadikan jarak tak berarti. Karena kami selalu ada untuk Indonesia.
Terus berinovasi, memberikan kenyamanan dalam setiap perjalanan. Pertamax dengan formula Pertatek untuk memastikan mesin bebas karat. menjaga mesin agar lebih tahan lama. Pemakaian bahan bakar yang lebih efisien. Karena kami tahu, bagi Anda setiap perjalanan memiliki makna.
Lebih baik Pertamax.
sudah ada kontak center PLN 123. Bisa tambah daya, bisa pasang baru, atau ada gangguan listrik, bisa bagi kontak center PLN 123. Bisa lewat telepon, email, dan Facebook juga bisa nih. Yang paling seru lewat Twitter.
Kalau gitu, Mama bisa ngumpul di sana lebih lama lagi dong. Urusan ke PLN bisa kapan aja kan?
Kontak center PLN 123. Kemudahan akses layanan listrik PLN. Kapan saja, di mana saja.
Kalau dipikirkan, rasa yang tumbuh ini hadir dari kebersamaanku dengannya. Rasa dekat dan peduli ada karena merasa sudah mengenal. Mengenalnya yang baik, dan memberikan keperluan dalam hidup, memberikanku segala keindahan. Bahkan mengenalnya yang sedih dan didera-derasnya perubahan bumi. Dia adalah alam. Aku menaruh kepercayaan kepadanya ketika berada di wilayahnya. Percaya bahwa sekeras apapun dia menerpa, aku yakin semua akan baik pada waktunya jika kita juga menjaganya.
Anak baru, sini. Aku mau nomor kamu now. Maksud saya nomor rekening. Memang kamu nggak mau gajian?
Belum punya.
Bikin dong now.
Zaman now, buka tabungan, tinggal scan aja. Terus, ikuti langkah-langkah gampangnya. Gak pakai download app, jadi gak boros kuota, apalagi memori.
Nomor HP kamu?
Butuh buka tabungan now.
Saatnya mandiri.
Yes, akhirnya laku juga gue. Pinjam rekening mandiri lu dong. Ada yang mau transfer ke gue nih, penting.
Nggak banget. Tuh.
Zaman now, buka tabungan, tinggal scan aja. Terus, ikuti langkah-langkah gampangnya. Gak pakai download app, jadi gak boros kuota, apalagi memori.
Laris manis nih online store-nya.
Kak, boleh kirim foto saya tadi?
Foto?
Butuh buka tabungan now.
Saatnya mandiri.
Yeah, dapat tuh. Tinggal satu bro, harus bayar now. Tapi pakai rekening mandiri, gua adanya cash.
Scan now aja.
Bro, scan now.
Zaman now, buka tabungan, tinggal scan aja. Terus, ikuti langkah-langkah gampangnya. Gak pakai download app, jadi gak boros kuota, apalagi memori.
Helm lu kok beda? Sengaja, beli promo dapat 2.
Butuh buka tabungan now.
Saatnya mandiri.
Daripada handphone kamu hanya diam tergeletak, kamu sudah coba belum menelpon teman lama dan menanyakan kabarnya?
Halo Jaya. Lagi pusing soal toko.
Pernah nggak bantu posting dagangan baru teman kamu? Pernah coba belanja untuk mereka yang penting buat kamu? Semoga Hari Merdeka di tahun yang sulit ini bukan hanya jadi slogan semata, tapi jadi titik pengingat untuk saling membantu apa yang kita bisa untuk sesama. Kami akan selalu ada bersama kamu dan handphonemu. Sedikit di sini, sedikit di sana, sebagai satu bangsa, satu Indonesia.
Pagi, masker.
dianugerahi dengan kekayaan alam yang melimpah. Lautan luas merajut ribuan gugusan pulau, membentuk untayan Zamrud Khatulistiwa. Selat Malaka yang berada di beranda depan Indonesia adalah jalur pelayaran terpenting di dunia. Pelindo I hadir sebagai perusahaan pelabuhan utama di Selat Malaka yang merupakan perairan tersibuk di dunia dan menjadi titik penting perdagangan global. Pelindo I, Indonesia Gateway.
Mau buka rekening tapi mager? Pakai Brimo. Buka rekening langsung dari HP. Login keseruanmu, download Brimo sekarang. Mau gampang login? Pakai Brimo. Bisa fingerprint dan Face ID. Login keseruanmu, download Brimo sekarang. Gak bawa kartu ATM? Pakai Brimo. Tarik tunai di ATM gak pakai kartu. Login keseruanmu, download Brimo sekarang. Ribet nginget nomor rekening? Pakai Brimo. Rekening bisa pakai nama alias. Login keseruanmu, download Brimo sekarang.
Kami selalu ada, satukan perbedaan dalam semangat kebangsaan. Kami selalu ada hingga pelosok Nusantara. Hadirkan kemudahan menjadi nyata. Kami selalu ada, wujudkan mimpi. Bagi seluruh anak negeri. Kami selalu ada, dekatkan hati, jadikan jarak tak berarti. Karena kami selalu ada untuk Indonesia.
Terus berinovasi, memberikan kenyamanan dalam setiap perjalanan. Pertamax dengan formula Pertatek untuk memastikan mesin bebas karat. Menjaga mesin agar lebih tahan lama. Pemakaian bahan bakar yang lebih efisien. Karena kami tahu, bagi Anda setiap perjalanan memiliki makna.
Lebih baik Pertamax.
Sudah ada kontak center PLN 123. Bisa tambah daya, bisa pasang baru, atau ada gangguan listrik, bisa bagi kontak center PLN 123. Bisa lewat telepon, email, dan Facebook juga bisa nih. Yang paling seru lewat Twitter.
Kalau gitu, Mama bisa ngumpul di sana lebih lama lagi dong. Urusan ke PLN bisa kapan aja kan?
Kontak center PLN 123. Kemudahan akses layanan listrik PLN. Kapan saja, di mana saja.
Kalau dipikirkan, rasa yang tumbuh ini hadir dari kebersamaanku dengannya. Rasa dekat dan peduli ada karena merasa sudah mengenal. Mengenalnya yang baik, dan memberikan keperluan dalam hidup, memberikanku segala keindahan. Bahkan mengenalnya yang sedih dan didera-derasnya perubahan bumi. Dia adalah alam. Aku menaruh kepercayaan kepadanya ketika berada di wilayahnya. Percaya bahwa sekeras apapun dia menerpa, aku yakin semua akan baik pada waktunya jika kita juga menjaganya.
Anak baru, sini. Aku mau nomor kamu now. Maksud saya nomor rekening. Memang kamu nggak mau gajian?
Belum punya.
Bikin dong now.
Zaman now, buka tabungan, tinggal scan aja. Terus, ikuti langkah-langkah gampangnya. Gak pakai download app, jadi gak boros kuota, apalagi memori.
Nomor HP kamu?
Butuh buka tabungan now.
Saatnya mandiri. Yes, akhirnya laku juga gue. Pinjam rekening mandiri lu dong. Ada yang mau transfer ke gue nih, penting.
Nggak banget. Tuh.
Zaman now, buka tabungan, tinggal scan aja. Terus, ikuti langkah-langkah gampangnya. Gak pakai download app, jadi gak boros kuota, apalagi memori.
Laris manis nih online store-nya.
Kak, boleh kirim foto saya tadi?
Foto?
Butuh buka tabungan now.
Yeah, dapat tuh. Tinggal satu bro, harus bayar now. Tapi pakai rekening mandiri, gua adanya cash.
Scan now aja.
Bro, scan now.
Zaman now, buka tabungan, tinggal scan aja. Terus, ikuti langkah-langkah gampangnya. Gak pakai download app, jadi gak boros kuota, apalagi memori.
Helm lu kok beda? Sengaja beli promo dapat 2.
Butuh buka tabungan now.
Saatnya mandiri.
Daripada handphone kamu hanya diam tergeletak, kamu sudah coba belum menelpon teman lama dan menanyakan kabarnya?
Halo Jaya. Lagi pusing soal toko.
Pernah nggak bantu posting dagangan baru teman kamu? Pernah coba belanja untuk mereka yang penting buat kamu? Semoga Hari Merdeka di tahun yang sulit ini bukan hanya jadi slogan semata, tapi jadi titik pengingat untuk saling membantu apa yang kita bisa untuk sesama. Kami akan selalu ada bersama kamu dan handphonemu. Sedikit di sini, sedikit di sana, sebagai satu bangsa, satu Indonesia.
Pagi. Masker.
Negeri ini dianugerahi dengan kekayaan alam yang melimpah. Lautan luas merajut ribuan gugusan pulau, membentuk untayan zamrud khatulistiwa. Selat Malaka yang berada di beranda depan Indonesia adalah jalur pelayaran terpenting di dunia. Pelindo 1 hadir sebagai perusahaan pelabuhan utama di Selat Malaka yang merupakan perairan tersibuk di dunia dan menjadi titik penting perdagangan global. Pelindo 1 Indonesia Gateway.
Mau buka rekening tapi mager? Pakai Brimo. Buka rekening langsung dari HP. Login keseruanmu, download Brimo sekarang. Mau gampang login? Pakai Brimo. Bisa fingerprint dan Face ID. Login keseruanmu, download Brimo sekarang. Gak bawa kartu ATM? Pakai Brimo. Tarik tunai di ATM gak pakai kartu. Login keseruanmu, download Brimo sekarang. Ribet nginget nomor rekening? Pakai Brimo. Rekening bisa pakai nama alias. Login keseruanmu, download Brimo sekarang.
Kami selalu ada, satukan perbedaan dalam semangat kebangsaan. Kami selalu ada hingga pelosok Nusantara. Hadirkan kemudahan menjadi nyata. Kami selalu ada, wujudkan mimpi. Bagi seluruh anak negeri. Kami selalu ada, dekatkan hati, jadikan jarak tak berarti. Karena kami selalu ada untuk Indonesia.
Terus berinovasi, memberikan kenyamanan dalam setiap perjalanan. Pertamax dengan formula Pertatek untuk memastikan mesin bebas karat. menjaga mesin agar lebih tahan lama. Pemakaian bahan bakar yang lebih efisien. Karena kami tahu, bagi Anda setiap perjalanan memiliki makna.
Lebih baik Pertamax.
Distinguished speakers and participants, ladies and gentlemen, a very good morning and warm welcome to the second day of the conference. It is my pleasure to welcome you all to MICES 2020, Medan International Conference in Energy and Sustainability. This conference is hosted by IA-ITB-SU, the North Sumatra chapter of the Institut Teknologi Bandung Alumni Association, in collaboration with Institut Teknologi Bandung and Universitas Sumatera Utara, and supported by the Ministry of Energy and Mineral Resources of the Republic of Indonesia. My name is Dian Lumbantoruan, and I will be the MC for today's event. This year, Medan International Conference in Energy and Sustainability theme is Energy, COVID-19, and the Changing World.
Ada di HP kamu ya? Sama.
MICES 2020 brought together various experts from Indonesia, the Netherlands, and United Kingdom. We are honored to have our distinguished speakers and moderators. A very warm welcome from Medan, Insinyur Rida Mulyana, Directorate General of Electricity, Ministry of Energy and Mineral Resources, on behalf of Mr. Arifin Tasrif. And also a warm welcome, Professor Rido Watimena, Dean of the Faculty of Mining and Petroleum Engineering, Institute Technology of Bandung, and all our speakers and participants. This conference is expected to bring together from academia, researchers, practitioners, and policymakers the way in which we could address the situation, and also the way we could adjust the issue and new situation after the COVID-19 pandemic in relation to gather insights and inputs from the involved stakeholders. This conference would not have been possible without the support from our sponsors. We are grateful to have the support from PLN, SSP Group, Bank Mandiri, Mitsubishi Power Ltd, PT Telkomsel, Pelindo 1, Bank BRI, Shell Indonesia, Telkom, Pertamina, IMP Bentul Limited, PT Pupuk Indonesia, PT Pertamina Hulu Energi, PT Bukit Asam, Perusahaan Gas Negara, Premier Oil, and Perta Arun Gas. Thank you so much for your generosity and support. Our program today will be started with one keynote speech from our distinguished speaker, followed by two panel sessions and two keynote lecturers with speakers from Institut Teknologi Bandung Indonesia, Imperial College United Kingdom, Universitas Sumatera Utara Indonesia, University of Twente, the Netherlands. After the lunch break, we will continue with parallel sessions. We are delighted to have all our distinguished speakers with us today. And for the participants, you can join the session through Zoom or from the YouTube channel, from the IA-ITB-SU channel on YouTube. Distinguished participants, ladies and gentlemen, allow me to welcome the first keynote speech for today. And as the moderator, I would introduce Professor Ridho Watimena, MT, PhD. Professor Watimena received his bachelor and master's degree from Institut Teknologi Bandung and doctorate degree in 2003 from University of Queensland, Australia. The floor is yours, Professor Ridho Watimena.
Okay, thank you very much, Dian. Very good morning, ladies and gentlemen. It is a very great pleasure for me to chair this session. In this session, according to the committee, we will have two speakers. The first one, let me introduce to you. We will have Dr. Ahmad Perwira Tarigan as our first speaker. Dr. Tarigan graduated from Geodetic Engineering of ITB in 1990 and got his master degree from Civil Engineering, University of Florida in 1996, and his PhD in Coastal Engineering from UTM Malaysia. Pak Ahmad is now lecturer at the Civil Engineering Department in Universitas Sumatera Utara, also as the head of Civil Engineering Program in USU. Pak Ahmad also commissioner of PT Pelindo I. The presentation of Pak Ahmad would be renewable energy source selection for a green port with analytical hierarchy process. Without further ado, ladies and gentlemen, please welcome Pak Ahmad Perwira Tarigan.
Okay. All right. Thank you, Prof. Ridho, for the nice introduction. I would like, first of all, to thank you for all the participants to join the session. And my today's presentation will be titled Renewable Energy Source Selection for a Green Port. And I'm honored and delighted to inform you that the co-authors are 4 persons. They are MD Mubasirul Hassan. Hassan is an environmental monitoring and management specialist working for Hyundai Engineering Construction, and he is now living in Singapore. And Professor Dr. Ahmad Khairi Abdul Wahab, he is the head of the Coastal and Offshore Engineering Institute at the University Teknologi Malaysia. He is my former supervisor when I did my PhD. And the third one is Professor Elhadou Guetche. He is my colleague working as a professor in France in the Université Polytechnique Hauts de France Institute, IEMN DOAE. I got an invitation from him 2 years ago, and I got a visit nice to his university. And last but not least is Mr. Ahmad Jamaluddin. He is the Chief Commissioner of Pelindo I. All right. This is going to be my outline of presentation. We are going to, first of all, to look at the objectives, and then I'm going to go over a little bit about the concept of green port and the case of study for port of Kuala Tanjung. And then next, we are going to see the possibility of the energy that is compared in the study. And of course, the tool that is used in this study is the AHP, the analytical hierarchy process. And before conclusion, we are going to have a little bit sensitivity analysis. All right. So the objectives is, number one, to promote the concept and implementation of the green port concept. So this is the idea behind this paper. We would like to promote, we would like to give what you call driving force to the implementation of the green port. And number two is we would like to deal with AHP, to apply AHP for selecting renewable energy sources. And in this case is for the port of Kuala Tanjung. All right, so the background of the study is that we know the port usually is the location of a hotspot for pollution because it is the meeting point from the sea and from the land. From the sea, we know that ships is coming to the port to have a berth and do the loading and unloading process. And from the land, we have inland transportation by trucks, by the river. And also the problem is aggravating because usually in the port locality, we have like the industrial estate where the manufacturing is there. And then also in more aggravating is that we have slum areas with densely populated communities situated near to the port. So it is going to be a hotspot for pollution. So in this case, then we need to have something to bring up for the solution, and the concept is green port. It is like green infrastructure. Then for the port, we would like to say the so-called green port. So the concept behind the green port is that we would like to balance between the economic demands and the environment challenge. So if you talk only environment challenge, so you only want to protect environment. On the other side, if you only talk about focus only on the economic demands, then you are only interested in economic development. So it is like separated. Then for the green port, we would like to use creativity and innovation to integrate between the protected environment and economic development so that we have the healthier working conditions. Then when we have healthier working condition, then we can hope that we are going to have more competitive advantage in terms of human capital, in terms of financial, in terms of commercial, operational of the seaport itself. But we need consider not only the port, but also for the society, the community around the port. So the concept of the green port can be evaluated using the criteria that I show you here. There are 5 criteria, and what we would like to focus here in the study is this yellow one, which is the usage of energy and resource. So the whole concept should look into the whole area, holistic study, but then in the study we limit our focus only on the usage of energy and resources. Of course, we have also problem of pollution, then we need to do waste handling, and we need to have a good water quality, air quality. But again, the study is limited on the side of usage of energy, and especially we focus on the renewable energy sources that we can use for the seaport. All right, so this figure shows you the location of Kuala Tanjung, and that you can see that it is on the east coast of North Sumatra. And if you drive from Medan, it's like 2 or 3 hours at the most from Medan, because there is already Jalan Tol, highway that you can use. So it's very convenient to use the Jalan Tol now, the highway. And as you can see that Kuala Tanjung is very near to the Semangke, Semangke's special economic zone. All right, this figure shows you the stages of development that we would like to do for the port of Kuala Tanjung. So as you can see that we have 4 stages. So we are now still in the first stage. We are going to achieve up to the second stage. As you see, the electrical power needed is up to only less than 10 megawatt. But then if we are going to have the second stage, which is the industrial estate, then we are going to need up to 400 megawatts. So a lot of energy will be needed in the context of the development of the Port of Kuala Tanjung, because Port of Kuala Tanjung is going to be Indonesia logistic and supply chain hub for the western region of Indonesia. That is the long-term goal. All right, now we move on the possibility or the potentiality of the renewable energy sources that we are going to look in the study. As you know, we are going to look into the sources of solar energy, and then biomass, and then wind energy, and the last one is wave energy. So first, I would like to go over a little bit about the solar energy. And what is I'm showing you here is that you can use application from internet. Yeah, internet very nice. You can use this website here, Global Solar Atlas Info, Global PV Potential Study. This is a website that you can use to evaluate the potentiality of the solar energy in one location. So as you can see here for Indonesia, we got like the average of 4.75 kilowatt hour per meter squared. So it's quite nice. And you can see also in this map that the red area is the area which has the biggest potential. And then I believe that Port of Kuala Tanjung is one location in the red area. All right. For biomass, because
Pak Ahmad,
yes,
could you put it in slideshow, please, so everybody can have bigger picture.
Oh, okay. Thank you, Prof. Rido, for reminding me. All right.
Thank you, Pak.
All right. As you know that North Sumatra is very well known with the oil palm. So the largest commodity that we have in the province of North Sumatra is oil palm. So we're going to have the amount of oil palm waste is very abundant. So if you want to do solar, what do you call biomass energy, so it's not a problem in terms of the sources. All right, now we would like to look at the wind data for wind energy, and then I got my student to do this data analysis using the data from BMKG, the hydrologic Meteorology Agency. And this is the data from the station in Kuala Namu Airport, which is very new. So the data is only, we got only 3 years, but it's okay to look a little bit about the potentiality. And then yes, you can see that almost like more than 80%, the wind speed is above 4 meters per second. So it has the potentiality for the wind energy. Okay, we move on to look at the possibility of wave energy. And then what we do here is that from the wind data, we can, in case, we can estimate the wave height. And then as you can see also here, that the wave height is quite moderate, not really big, but okay to harness the energy from the wave data. As you can see that about 50-50, 50% less than 1 meter, 50% possibility to be larger than 1 meter, then it's okay if you want to combine the energy. All right, so next, it is the tool that we are going to use in the study. It is the AHP, the analytical hierarchical process. So if you talk about AHP, you need to understand that there are 4 main features that is inside the AHP. The first is that we have to have the structural hierarchy, in which we show the goal, the criteria, and the alternative. Yeah. That is this. I will show you the example of structural hierarchy, and then feature number 2 in AHP, we should have expert or professional judgment for pairwise comparison. So this is going to be comparison between criteria, comparison between alternative, and then we are going to have the third one, matrix eigenvector and eigenvalues, to get the weight or the priority factor, and then the consistency ratio, to make sure that our evaluation from the expert judgment is okay. And last step is the linear combination to get the overall value. This is going to be the last step in the computation in AHP. We are going to have the score for each alternative, to compare the score for each alternative. All right, so this is the hierarchy that I mentioned. So as you can see that we have 4 levels. Level number 1, we should have the goal. The goal is the selecting the most suitable renewable energy sources. And level number 2, we have the criteria. We have 4 criteria in this case. And then this criteria is obtained based on the study of literature, and also based on the opinion of the expert. And level number 3 is the sub-criteria, and level number 4 is the alternative energies. So we are going to have pairwise comparison for the main criteria. We are going to have pairwise comparison for the sub-criteria, and lastly, we are going to have pairwise comparison for the alternatives. All right. So before I show you the result of the pairwise comparison, the reference that we need to have for the evaluation of the comparison is this table, because from this table, then we are going to have more objective evaluation of the comparison of the renewable sources. So as you can see, in the first column, it is the economy. This is the environment, technology, sociality, locality. This is the main criteria, and the first row here is the energy alternative. So we compare each other. So this is going to be our basis to evaluate the comparison, and also this is going to be the basis for the expert to give the judgment. All right, so this is the computation step. It's going to be like 7 steps. Then I will show you one by one very quickly. The first step is the pairwise comparison matrix. Yeah, this can be done, of course, after we have the hierarchy and then the judgment from the professional or from the expert. So this is the pairwise comparison. Yeah. And then from this pairwise comparison matrix, then we can continue to evaluate the priority factor and the consistency ratio. But please note that in EHP, we have from 1 to 9 score. One is in the same interest, and 9 is extremely preferable. Yeah. So this is going to be limited up from 1 to the level 9. All right. And then also the matrix is symmetrical. Okay, so after forming the pairwise comparison matrix, we do the calculation for the eigenvector and eigenvalue, and we use MATLAB here. And I show you a very short command using MATLAB to get the eigenvector and eigenvalue. And in the step 3, from the eigenvector, we get the priority factor, also using MATLAB. Then here you can see that we have the weight out of priority. Weight of economy is 0.33, weight for the environment is 0.36, weight of the technology is 0.16, and weight of society is 0.15. And from this evaluation, we can see that the environment got the most weighted criteria, followed by economy, technology, and society. Okay, to check whether it is consistent or not, then we have to use the eigenvalue to calculate the consistency index and to calculate the consistency ratio, CR. So if CR here is 0.0076, it is quite small, so it is less than 1. If it is still less than 1, then it is okay, and we can say that the PCM, pairwise comparison matrix, is consistent. All right, so we are going to do the same for the level 3. This is going to be level 3. This one we do for level 2 for the main criteria. This is for the sub criteria. Yeah, fortunately, the level 2 we only have matrix with the size of 2, so quite easy. And this is the weight, yeah, for the investment, for operation maintenance, for the noise, for the impact on the ecosystem, for the maximum capacity, resource availability, for job creation, port locality. So because the size of the matrix is only 2 times 2, so actually the EHP is not necessary. All right, now we come to the alternative. This is the pairwise comparison matrix for the alternative. As you know that we use 4 alternatives: solar, wind, biomass, and waves. And then we do the same steps as the main criteria as before. And then the result is here. This is the Pareto factor, the weight of each alternative for investment. And this is on the bottom of the table. As you can see, this is the calculation for the consistency ratio. The consistency ratio is 0.03, which is less than 0.01, less than 0.1. 0.1 is okay. Less than 0.1 is okay. So this is 0.03, so it's still okay. So we say that this is consistent. Then the same also for each pairwise comparison matrix. This is for the investment in terms of the alternative. And then this is for operation and maintenance costs for the all alternatives. And then next, the noise. This is PCM, pairwise comparison matrix for noise in terms of the energy compared. And then this is the pairwise comparison matrix for the ecosystem. Note that in each PCM, pairwise comparison matrix, the weight is on the last column. This is on the last column. And for capacity factor, for the availability, reliability, this is for the in terms of technology, And then job creation and port locality, this is in terms of what you call sociality and locality aspect. All right. So after all PCMs are processed, then we got all the weights, in the level 2, in the level 3, and the level 4. So we can fill out all the weights here back to the hierarchy for all the matrix. Then after this, we can do the linear combination. As I mentioned before, the last feature of the EHP is the linear combination for the overall weight. So this is the linear combination of the solar, linear combination for the wind energy, linear combination for the biomass, linear combination for the wave, to get the score for solar, to get the score for wind, to get the score for biomass, to get the score for wave. So the score we can put nicely on the table. This is all the score. So using the linear combination, we can calculate using Excel, for example. Then on the last column, this is the result. This is the result of linear combination for the solar, 0.35, while the overall weight for wind is 0.30. Then the weight or priority of the biomass is 0.23, and the least one is for the wave, which is 0.12. So from here, we can say that solar energy is the best alternative. So the next one is actually the sensitivity analysis. In the sensitivity analysis, we would like to see whether the selection of the best alternative, which is here in the case is the solar energy, is stable enough or not. Then we from the sensitivity analysis, we can see that it is quite stable. We need to make a very big change before the superiority of the solar energy can be replaced by the other alternative. So as you can see here, if we make economy zero, then of course solar will be very superior, because then environment is going to be the king, and solar is very much friendly, eco-friendly. So solar will be again back to be number one. And on the other hand, if we do the other side, environment is zero, then we put all of this proportion to the economy, then we are going to have biomass as the number one of selection. So in this case, we can say that biomass is still have the potential to be used in the locality, in the area of the seaport of Kuala Tanjung. If environment is neglected, maybe because this is already renewable energy. All right. Okay, so we say that in the sensitivity analysis, solar energy is ranked number one in the environmental aspect. If we would like to focus on the main criteria, then we can say solar energy is in the environmental aspect is quite superior. But if you look into the economic aspect, wind energy is the rank number one. Then biomass is superior in terms of technology and society. And because biomass have the superiority of the two aspects, while the other only one aspect, then we can say that biomass could be superior to others. Because as I mentioned in the background, that North Sumatra has a largest commodity in terms of oil palm. So we have to take a note, because this is based on the study case, and also this is from the expert judgment. So changes might happen if we use it on different ports, or changes may happen also if we evaluate it from different experts. All right. In conclusion, I would like to point out 5 points. Point number one, this paper has presented the AHP-based decision-making method to assess the selection of renewable energy sources in the context of Greenport. So in the point number one, we say that we have successfully demonstrated the applicability of the EHP for selecting the renewable energy sources. And point number two, it is found that solar energy is the most preferred alternative, followed by wind energy, biomass, and wave energy. And if we understand from the trend that we see, whereby the technology of solar cells is becoming more efficient and cheaper, so this is quite okay in terms of the trend that we see currently. All right. Point number three, we understand that we cannot skip the other alternative. We cannot depend only solar. Based on our sensitive analysis, that biomass can also be superior. So I think the mixed use, we think that the mixed use, the energy mix, should also be considered for the more optimal solution to a long-term energy problem. And of course, we know that energy efficiency is one very critical solution that should be included for the concept of green seaport. So also we see that we see the chance that in the further research we would like to consider in the main criteria for including the energy efficiency. Last but not least, we really see that the concept of green port should be put forward, and the ideas should be distributed and implemented so that we can have more competitive seaports, and the result is that we hope we are going to have more sustainable economic development, also with more protected environment. I think I should end my presentation here. I would like to get back to Professor Rido. Thank you, Prof. Rido.
Thank you, Pak Ahmad. I'm so sorry that we are running out of time. So I have two questions here in the Q&A chat, but according to the committee, the question will be forwarded to our question form. So if you could answer the question in the question form, it would be great for the participants, Pak Ahmad. So once again, thank you, Pak Ahmad. Very good presentation. We got some insight about renewable energy for the Kuala Tanjung Port. And as you conclude, solar energy should be made as a priority for the renewable energy resources. Once again, thank you, Pak Ahmad. Have a good time, and you can close your presentation.
All right. Thank you, Prof. Rido. There is two questions. I just make a quick answer for the two questions. The question number one is about the price. I'm sorry to answer that I'm not selling any technology, so I am not sure about the price, but I believe the price is going to be very competitive now, because there is local content also made in Indonesia, and then also many selection from the imported solar panels. So I think competition among the sellers is quite sharp. Yeah, so I believe that is going to be cheaper in the future. And so question number two is about how to cope with the intermittency. Of course, intermittency should be solved by using the main energy from PLN, I guess. Yeah, we know that we cannot depend only from the solar energy. So I think in the system of on-grid will be very nice if we can combine the intermittency with available resource from PLN. That's all I can say. Then thank you again, Prof. Rido, and all the audience. And I hope this study can enlighten a little bit about green port and also the renewable energy sources in the context of seaport. Thank you very much.
Okay. Could you stop your screen
All right.
share?
Oh, sorry. sorry, Prof. Rido. Thank you. All right.
Okay. Ladies and gentlemen, we will have the second speakers for today's this morning session. Let me introduce our second speakers. I think Pak Rida is already in the Zoom. Engineer Rida Mulyana, Master of Science. Pak Rida graduated from ITB, majoring in petroleum engineering in 1988, and then got his master degree from London University in UK, also in petroleum engineering. His career, long path of his career, spent in the Minister of Mine and Energy Resources. Pak Rida is now Director General of Electricity, and before that, Pak Rida was the Director General of New Renewable Energy and Energy Conservation. I believe we will have very good insight from Pak Rida through his presentation, which is about electricity development, energy mix challenges and opportunities after COVID-19 pandemic. So, Pak Rida, the screen is yours, Pak.
Terima kasih Pak Profesor Rido atas kesempatannya. On behalf of the Minister of Energy and Mineral Resources, Bapak Arifin Tasrif, I would like to apologize that the Minister, for some reason, is unable to join this event. So I would like to thank to you all for allowing me to deliver his speech this morning. Honorable Chairman and Speakers, distinguished participants, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Good morning to all of you from Jakarta, Indonesia. To begin, please allow me to convey my highest appreciation to the Chairman of MICE, or Medan International Conference on Energy and Sustainability 2020, for initiating and inviting me to this event. It is indeed a great honor for me to be one of the key participants in this forum. And I sincerely hope that we can have enlightening discussion on MICE 2020 with the topic, the roadmap of Indonesia energy security, energy mix challenge and opportunity after COVID-19 pandemic. Distinguished participants, ladies and gentlemen, during pandemic COVID-19, all economic sector are experiencing tough situation, including energy sector. Global demand of energy is decreasing due to isolation and lockdown. This could hinder sustainable energy development. This hard situation we face today should be our momentum to promote energy transition through renewable energy and energy efficiency development. We should consider that renewable energy and energy efficiency will play a key role of post-COVID-19 plan and assure energy security in the long term. Indonesia has set a target of 23% renewable energy in the energy mix by 2025. This policy, combined with Indonesia's commitment to reduce emission up to 29% in 2030, is a clear path to a cleaner and more sustainable energy system. The government continues to implement the strategic effort toward clean energy development. Among others, the share of renewable energy in electricity generation would increase by utilizing local renewable energy sources such as geothermal, hydro, solar, biomass, and also wind. Second, the implementation of biodiesel mandatory policy. Indonesia has successfully implemented biodiesel 20%, or we call it as P20, in 2016, and had started to implement B30 to all related sectors, including transportation and industry since last year. Currently, the government is also working on the development of hydrotreated vegetable oil, or we call as a green fuel. And third, the diesel engine power plant conversion program to gas or renewable energy. It is expected that this program could reduce fossil fuel consumption and at the same time could increase the renewable energy portion in our energy mix. Fourth, the acceleration of the waste to energy power plant development program. As you know, there are 12 cities that have been selected as the beginning of the construction of waste processing plant. Fifth, the use of biomass to reduce emission in large-scale industry. For example, in cement, steel, as well as pulp and paper industry. Also, the government is now preparing the use of biomass as co-firing with coal to reduce emission in the power plant throughout the country. Six, introducing what we call Renewable Energy-Based Industry Development Program, or REBIT, and Renewable Energy-Based Economic Development Program, or REBET. These two programs are designed to accelerate the use of renewable energy in industrial areas and special economic zones, as well as to support the development of local economy in remote or off-grid areas. And seven, the acceleration of the battery-based electric motor vehicle program for road transportation. This program could reduce the dependencies on fuel import and increasing local energy use for power generation, such as renewable energy and gas. Distinguished participants, ladies and gentlemen, the government continue to encourage the use of renewable energy, which will increase the role of renewable energy in the energy mix. This will suppress the role of fossil energy, especially oil. Although the role of oil is getting smaller, the volume will continue to increase. Therefore, oil and gas exploration and exploitation activities will still continue to be improved through policy as follows. One, making policy adjustment, such as the plan of oil and gas block auction will be carried out next year to provide more certainty and convenience for investors. Secondly, providing incentive, both fiscal and non-fiscal, as well as simplifying the licensing process. Third, strengthening data and study through cooperation with international research or survey institutions. This is expected to increase upstream oil and gas exploration activities. And fourth, encouraging oil companies to implement good reservoir management, maintain operational efficiency, and utilize technology such as AOR and biochemical. And fifth, optimizing domestic gas utilization. Indonesia has targeted that gas would take 22% of its share in the energy mix by 2025 and 24% by 2050. Distinguished participants, ladies and gentlemen, infrastructure development is also government concern to be able to provide energy to the people, reduce export, and provide multiplier effect for the people's economy. Currently, we are accelerating the progress of the following project. Number one, the acceleration of completion of 4 refinery development master plan, or what we call it as RGMP, and 2 grassroots refinery or GRR. The projects are expected to increase crude oil processing capacity from 1 million BPD or barrel per day to about 1.9 million BPD or barrel per day. And secondly, the development of gas pipeline infrastructure, especially in 3 gas pipeline transmission, namely tie-in West Natuna transportation system to Pemping Island, Semangke to Dumai, and from Cirebon to Semarang. These gas pipeline transmissions are dedicated to meet domestic demand, especially for industry as well as for power plants. Third, we are going to develop what we call as LNG small scale and virtual pipeline development. This plan is to secure energy supply in particular areas with geographical constraints, such as in scattered small islands, especially in the eastern part of the country. Fourth, the conversion of diesel of natural gas for power plant. This program is aimed to reduce heavy fuel oil import and reduce high-speed diesel consumption. And last, fifth, the added value of coal. We have a program to build 3 coal upgrading facilities to increase calories, coal gasification, one of which is the methyl ether or DMA, as a substitute for LPG, and then briquette factories and coke making facility with a capacity of 1 million ton. Distinguished participants and ladies and gentlemen, the energy development that I have mentioned above require regulation that can provide business certainty and security. Thus, the government create policy as follows. 1, a draft of presidential regulation regarding the tariff, including feed-in tariff of renewable energy, that will be soon issued, hopefully before the end of this year. With this new regulation, there will be an improvement in the price of electricity sold by the IPP or independent power producer to state-owned electricity company or PLN. Secondly, the regulation concerning adjustment of gas price for a certain industry that is expected to increase the national industry competitiveness. And thirdly, the regulation concerning the form and flexibility of PSG or production sharing contract. Oil and gas companies in Indonesia may now choose to either use of cost recovery or gross split based PSG. These changes are intended to provide legal certainty and improve investment in the oil and gas industry. And fourth, the revision of mineral and coal mining law. The regulation increase added value, boosting exploration, more concern about reclamation and post-mining activities, and set a minimum of 51% divestment. The law is expected to boost investment in the mining sector. Distinguished participants, ladies and gentlemen, we need an extraordinary work in order to increase energy security by prioritizing renewable energy development to reach target 23% in the energy mix by 2025 and promoting cleaner fossil fuel utilization. Thank you very much for the opportunity. I wish you a fruitful deliberation and successful discussion. Thank you, Prof. Back to you.
Okay, thank you, Pak Rida. I got the information that Pak Rida will have another agenda, so we cannot have a question and answer session for Pak Rida. So let me conclude this session by first saying thank you to Parida, who already with us this morning. And if we can see what we got from the presentation, Parida informed us about the global point of the renewable energy and what is planned by the government and what can we participate in the development of energy. And before Parida, Pak Ahmad already informed us about the potential renewable energy in Sumatera Utara, in North Sumatra, especially for Kuala Tanjung development. So I would say we already have very good session this morning about renewable energy. So once again, thank you very much for Pak Ahmad. Thank you very much for Parida.
My pleasure, Pak.
Have a safe and healthy day in Jakarta, Parida, and in Medan, Pak Ahmad.
Thank you.
We conclude this session by sending you warm regards from our lovely campus in Bandung. So
Thank you, Frida.
Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Baik, terima kasih, Bapak.
Back to you, Dian.
Thank you, Pak Rido. Thank you very much for our keynote speakers, Dr. Ahmad Parwira Tarigan, Universitas Sumatera Utara, Insinyur Rida Mulyana, MSc, Director General of Electricity, Ministry of Energy and Mineral Resources, on behalf of Honorable Mr. Arifin Tasrif, Minister of Energy and Mineral Resources, and of course our moderator, terima kasih, Professor Rido Watimena, for the engaging session. Please stay a moment, gentlemen, for a photo-taking session. Our Zoom moderator will take a screenshot. Allow me to count. 1, 2, 3. Another 1. 1, 2, 3. Okay, thank you. Because in this online environment, we have to adapt. So usually we will standing together in the stage, yeah. But right now we are in the online stage, and this is a special opportunity because all the speakers and moderator are actually in different cities. So, and also thank you so much again, our speakers and moderator. And we are delighted to see more participants joining in. Welcome, dear participant, to the second day of Medan International Conference on Energy and Sustainability, MICS 2020. MICS is part of 100th anniversary of the Institut Teknologi Bandung, the oldest engineering university in Indonesia. Thank you for attending MICS 2020. And we also would like to inform that the chat function for participants is disabled during the session, but we invite you to submit your question via the link in the chat. So you can see in the chat box, there's a bit.ly/question form MICS 2020. We also got some question about the presenters' materials. And later, we will ask the speakers' consent. And if they approve, we will share the documents via the website, the MICS website, which is 100, let me say it in Indonesia, 100 tahun ITB -ia-itbsumut.info. Our Zoom moderator will also put the name of our website in the chat box. Okay, continue on the Medan International Conference in Energy and Sustainability, or MICS 2020. We will hear from Dr. IGBN Maketiharta, Chemical Reaction Engineering and Catalysis Laboratory, Institut Teknologi Bandung, and Dr. Dani Pujianto, Imperial College London, in the next panel session. Allow me to introduce the moderator for this session. Dr. Eng Ahmad Ardian Korda, Head of Alloy Development and Characterization Laboratory, Institut Teknologi Bandung. Dr. Korda received his bachelor and master degree in metallurgy engineering from Institut Teknologi Bandung. In 2006, he received his doctorate of engineering in material science from Nagaoka University of Technology, Japan. Dr. Eng Ahmad Ardian Korda, the floor is yours.
Thank you very much, Mbak Dian. Can you hear my voice?
Ya, clear, Pak.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Good morning, dear honorable participants of the MISIS conference, colleagues and friends. May we all be in the good health and safety during this pandemic. Thank you for coming today. I'm Ahmad Akorda. I will be the moderator for this session. We have two speakers here. Each speaker will deliver a presentation for approximately 25 minutes. After all presentations have been delivered, a question and answer session will be followed. And participants can ask via the chat room. Questions that are asked directly may not be heard clearly, I think, due to connection problems. Sometimes I have also the problems. So the question can be written in the chat room and on the Zoom application. Conference participants now joining us, our first speakers, Dr. Makerti Harta. He graduated in 1997 at the Department of Chemical Engineering, ITB, Bandung Institute of Technology, and then completed his doctoral program from Chemical Engineering Universiteit Gent, Belgium. He is an associate professor in chemical engineering in ITB and currently serves as the head of graduate program in chemical engineering and as researcher in the laboratory of Center for Catalyst and Reaction Engineering, ITB. On this occasion, he will deliver his presentation entitled Biofuel, Opportunity for Development and Its Implication to Oil Palm Plantation. I think from the title, it seems that he will deliver a presentation about the development of biofuels in his laboratory at ITB, which previously we know received great attention from many stakeholders as well as from the government, I think, especially for its success in development Merah Putih catalyst. To Dr. Makerti Harta, we invite you to deliver your presentation. You have about 25 minutes. Please, Dr. Makerti Harta.
Thank you very much, Mr. Moderator. I would like to have the permission to share my presentation. Right. Can you see my presentation?
Yes.
This is my presentation. Okay, thank you very much. Distinguished participants, I'm very honored to be here, albeit virtually, to share information about the biofuel and its opportunity for development and its implication to oil palm plantation. I was asked by the committee to talk about our project on the development of palm oil based on palm-oil-based biofuel technology in Indonesia. First of all, please allow me to introduce myself again. I am Igusti Baguswara Makerti Harta from the Center for Catalysis Reaction Engineering and the Department of Chemical Engineering, ITB. Let me start my presentation with this information. Currently, Indonesia is the largest palm oil producer country in the world. Indonesia produces around 48 million tons of CPO per year. It's more than 55% of CPO world production. On the other hand, Indonesia imports a large amount of fossil crude oil and fossil fuel. Indonesia imports about 110 until 140 million barrel fossil crude oil per year. and 120 until 150 million barrel gasoline per year, making Indonesia the second largest gasoline importer country in the world after Mexico. It means that we have large opportunity to replace fuel importation by palm oil-based biofuel. We can see in this graph that the Indonesia CPO production is increasing rapidly. Yeah. This causes the supply of CPO in Indonesia to be very abundant, so that the world CPO price tend to continue to fall. Although recently world CPO prices have increased, we need the instrument we can use to control CPO prices. We cannot depend on the food sector only, because the food sector in Indonesia only absorb about 18 until 20% of Indonesia CPO production. Currently, the sector that can utilize large amount of excess supply of Indonesia CPO is the energy sector, so that we can use this sector as a tool to control CPO prices. This is the projection of the national CPO consumption for energy. Due to the mandatory utilization of B20 and B30 biodiesel, the Ministry of Energy and Mineral Resources projected that 30% of a country CPO production will be used for energy sector in the 2024. Hopefully, the ability to absorb this excess of CPO production will be strengthened when we produce biohydrocarbon fuel from CPO in 2024. For this reason, several parties are currently working together to develop biofuel production technology in Indonesia. The government, in collaboration with the universities, research institutions, together with the industries, private sectors, are working together through various schemes such as National Research Priority, National Strategic Project, and some other more, in developing palm oil-based biofuel processing technology in Indonesia. The ultimate goals of these activities are, of course, first, establishing the palm oil-based biofuel technology. Second, substitution the fossil fuel importation, and then increasing the national energy security. And finally, of course, establishing the welfare of palm oil farmers. The biggest problem that must be answered is, can our palm oil, which is very abundantly available, replace fossil fuel? What is the implementation strategy? What must be prepared to do this? Do we have the natural resources to make a biofuel? And how about the qualification of human resources? There will be a lot of questions that need to be answered and clarified. My answer to this question is yes, we can replace, if not all, some fossil fuel with the biofuel based on vegetable oil. Since Indonesia is the largest palm oil producer country in the world, this time I will talk about palm oil-based fuel. Palm oil-based biofuel produced in Indonesia are divided into two groups, oxygenated and biohydrocarbon fuels. Oxygenates are fuel that contain oxygen and have the same number of C atoms as fossil fuels. Their molecular structure is not exactly similar because it contains the oxygen, and in the case of the oxygenate from the palm oil, usually also contains a double bond in the middle of the molecular structure. This type of fuel has low stability and hygroscopic. In order to be used as a fuel in a motorized vehicle, this type of fuel must be mixed with the fossil fuel. An example of this type of fuel is biodiesel, or FAME, or fatty acid methyl ester. This type of fuel is currently popular with the name of B10, B20, B30. Yeah. The B30 is a blend of 30% of FAME with the 70% of fossil diesel. FAME is made by the catalytic esterification process by mixing palm oil with the methanol under unstable reaction condition. I will talk about it later. On the other hand, Biohydrocarbon are biofuel that have precisely the same molecular shape as fossil fuel. Thus, this type of energy sources can be used directly as fuel in internal combustion engine vehicle without the need to be mixed with the fossil fuel. Although in use, this biohydrocarbon diesel can be mixed with the diesel with the fossil diesel. So the terminology used for this type of fuel is DXX, D10, D20, or D100, for example. I want to go into a little bit more detail about what D100 is. What is the difference between D100 and B100? Let's talk a little about chemistry. Biodiesel, also known as a fatty acid methyl ester or FAME, is synthesized through the esterification reaction. It's made from the palm oil, and this ester has the same number carbon atom of 15, 17, 19, which is the same number of diesel fraction carbon atom. However, because this ester has a double bond in the middle of the molecular structure, it also contain oxygen. FAME has a low stability and must be mixed with the fossil diesel in its use. For example, B30 biodiesel. Meanwhile, biohydrocarbon diesel is made through the hydrodeoxygenation process of vegetable oil at high pressure and high temperature. If the feed is the palm oil, then the product is the biohydrocarbon diesel. If the feed is the palm kernel oil, the product will be the biohydrocarbon jet fuel or AFTUR. This biohydrocarbon fuel is a drop-in type of fuel. It can be used directly without being mixed with the fossil fuel because its molecule is precisely similar with the fossil fuel molecule. The benefits are, for example, the biohydrocarbon diesel. This fuel has a high cetan number and low content of sulfur compound. Biohydrocarbon diesel has several different names, such as UOP, called this type of diesel is green diesel. Meanwhile, Neste uses renewable diesel or hydrotreated vegetable oil. These are what we, Center for Catalysis and Reaction Engineering, ITB, have been doing so far. We have designed and developed the catalysts and processes to convert IFO, industrial vegetable oil, and ILO, industrial lauric or kernel oil, to produce the biohydrocarbon fuel. We produce biogasoline from the IFO through the cracking process. We convert IFO into the biohydrocarbon diesel by means of hydrodeoxygenation process. We also work to convert ILO to biohydrocarbon jet fuel through the hydrodeoxygenation and isomerization processes. All these processes need special design catalysts developed by ourselves, funded by the state-owned energy company Pertamina and BPDPKS Oil Palm Plantation Fund Management Agency. We have been developing these catalysts and processes since 2010 through laboratory tests, pilot tests in Pertamina Research and Technology Center and Institute Teknologi Bandung. And finally, performing commercial tests in Pertamina commercial units. For your information, the last two tests were carried out in March 2019 when we performed co-processing tests producing D12.5, and in last July 2020 when we performed the standalone scheme biohydrocarbon fuel production producing D100 biohydrocarbon fuel, meaning 100 biohydrocarbon fuel in product. To realize this development, we, together with the Ministry of Research and Technology, National Research and Innovation Agency, and the Ministry of Energy and Mineral Resources, are managing national strategic projects, focusing on the development and biofuel production technology in Indonesia. This slide is the simplified scheme of the development of palm oil-based biocarbon fuel technology integrated with the palm oil plantation managed by the Ministry of Research and Technology. In technological wise, there are three sectors that we are working with now. First, we are working to develop the IFO production unit, industrial vegetable oil in the production unit, to prepare the feedstock needed for the biohydrocarbon fuel industries. Second, we are developing, revamping, modifying the process technology to produce biohydrocarbon fuel, biogasoline, biohydrocarbon diesel, biohydrocarbon jet fuel through either a standalone scheme, production unit, or co-processing scheme using the existing Pertamina production unit. Third, to produce biohydrocarbon fuel, we need the catalyst. So we are also developing the catalyst production unit. This catalyst was specially designed and developed for biohydrocarbon fuel production from palm oil or palm kernel oil. This is the picture of diesel hydrotreating unit in Dumai refinery unit of Pertamina that we use for commercial biohydrocarbon fuel production tests using the catalyst developed by Pertamina and Institut Teknologi Bandung. Co-processing scheme means that the feed used for the fuel production is the mixture of the gas oil from the fossil crude oil and RBDPO, refined bleached deodorized palm oil. The product of this process scheme is D12.5. It can be seen from this graph, although it's a little bit too small, that the biohydrocarbon fuel produced by means of this co-processing scheme in Pertamina met all essential diesel characteristics needed, or even better. The Satan index is much higher than 48. The sulfur content is much lower than it needed, and the total acid number is much less than maximum value of 0.6. The additional trial was performed in the last July 2020 to produce the 100 by standalone scheme. This standalone scheme is the process scheme using only RBDPO without gas oil as a feed, producing D100. That's true that there are still a lot of issues that must be resolved. Some operation system have to be modified, for example. So then, I want to show some milestones of national catalyst and palm oil-based biohydrocarbon technology development. In 2009, the research collaboration between Pertamina and FTP was started. The development of the first generation of the HDO catalyst was produced to produce biohydrocarbon fuel from palm oil, and then it was carried out in the 2010 until 2012. The first trial of the co-processing using Pertamina production unit was performed in 2014. Based on this co-processing test, we did the catalyst modification. From 2016 until 2018, we modified the first generation of HDO catalyst, and we prepared and designed the second generation catalyst, which perform a bit differently, and its performance is much better than the first one. During this period, we also got funding from the BPDPKS, Oil Palm Plantation Fund Management Agency, to develop the catalyst and process to produce the biohydrocarbon gasoline from palm oil. The breakthrough was happened in the 2019 until 2020. D12.5 and the 100 commercial production tests were performed in Dumai refinery unit of Pertamina. We arranged a national research priority on biofuel coordinated by the Ministry of Research and Technology. We are collaborating with the Pertamina. Ministry of Research and Technology, Ministry of Energy and Mineral Resources to run a national strategic project on biofuel technology development. We succeeded to have the GVA on the National Catalyst Plan establishment. And we settled several downstream projects with BPDPKS. Yes, there are still a lot of things to do towards 2024, when we are dreaming to have a strong and complete system of palm oil-based biohydrocarbon fuel. This slide shows the detail of two national strategic projects for biofuel technology development, coordinated by the Ministry of Research and Technology on the left-hand side, and the Ministry of Energy and Mineral Resources on the right-hand side. The Ministry of Research and Technology coordinates activities that include the development and establishment of IFO factories in Musi Banyuasin and Pelalawan districts, the development and construction of pilot-scale cracking catalyst production units, construction of 1,000 liter per day biofuel plants, construction of commercial biofuel plants. These activities are summarized in the National Strategic Project entitled Development of an IFO and a biogasoline plant integrated with the smallholders palm oil plantation. Meanwhile, the Ministry of Energy and Mineral Resources coordinates other national strategic project activities entitled Development of Hydrocarbon Diesel and After Production Units. The activities covered in this project are the construction of the national catalyst factories, the construction of 1,000 liter per day biohydrocarbon diesel and after pilot plant, revamping Pertamina's unit for the production of biohydrocarbon diesel and after, and then the construction of 20,000 barrel per day hydrocarbon fuel plants. For example, this is the pilot unit for the biogasoline production from palm oil with the capacity of 1,000 liter per day. This unit is currently under construction. This unit is almost ready for the functional tests and commissioning. This pilot unit required about 18 times 15 square meters and is built to be mobile, so that can be moved easily. This unit is expected to be operational to produce the biogasoline by the end of this year. And this is the roadmap of our grand plan. I apologize that it is still written in Bahasa Indonesia. Basically, there are three major activities that are taking place currently. The first one is the upstream oil palm plantation system development activities. And then the second one is the preparation of the raw material for biofuel production, which are known as industrial vegetable oil. And then the third one is the development of the biofuel production technology. Yeah. So then imagine what would happen if the whole things could go on and be implemented. First, the concept of oil palm farming would be very different when the palm oil is intended to be used for the energy sector. There will be enormous opportunity to increase palm oil yield. Yeah. Due to the dry process innovation, the production cost will be cheaper. This will reduce the price of IFO as a raw material for biofuel to a very low level, so that the price of the biofuel is expected to be affordable. Second, all biofuel stakeholders are currently active to realizing the biofuel plants construction, both with the co-processing and the standalone schemes. Pertamina will build the commercial factories in the Pelaju, Cilacap, and modify the Dumai hydrotreating unit to produce the biocarbon diesel and after. Meanwhile, all Pertamina FCC units are ready to produce the biogasoline with the processing scheme, while the smaller scale biogasoline unit that can be built in the smallholder palm oil center using Merah Putih technology is being pursued. If this can be realized, what will happen? Two important things. First, the sovereignty of the people's palm oil can be upheld, since all Indonesia CPU can be absorbed by the biofuel production units. Second, national energy security can be improved. Ladies and gentlemen, we are dealing with big things. Finally, to close my presentation, I would like to acknowledge all my partners and all palm oil and biofuel stakeholders which have been supporting this project. Government, university, research center, research institution, industries, which have been collaborating, working together to build the IFO industries, to build the catalyst production plan, and to build biohydrocarbon fuel production plan. These processes are now still going on. Distinguished participants, this is the team member of the Center for Catalysis and Reaction Engineering, Institut Teknologi Bandung. I'll be very happy to answer all of your questions. Thank you very much for your attention.
Thank you very much, Dr. Makarti Harta. That is very interesting presentation. You actually still have about 5 minutes.
Yeah.
And actually, there is information from the committee that we have enough time, even extra time, because in the previous session, there were no questions for Pak Rida. So you invited to continue the presentation, or you can edit some explanation if there are any information that you can still share here, or maybe you want to add another explanation for your slide, maybe.
Yeah, for your... sorry.
Pak Rida, can I have a question, please?
Okay. Pak Ahmad, maybe we can start the session question and answer after the second panelist, Pak Ahmad. Is it okay?
All right. Okay, no problem.
Thank you very much, Pak Ahmad. Okay, Dr. Makarti, you maybe want to add some explanation, maybe?
From your
slide? Or maybe you can explain here how long process your laboratory pioneered long research in the field of biofuels and specifically your catalyst, Merah Putih catalyst, Pak Makarti.
Yeah, so things I want to explain about this process. Yeah, the catalyst and the process to produce the biohydrocarbon fuel has been started since 1980s. Somewhere, yeah, 1980s. So it has been 30 or 40 years research work to develop, to design. And to commercialize the catalyst and to design the process of to convert the vegetable oil into the biohydrocarbon fuel. This process using the vegetable oil, and then there are a lot of concern about it, because especially the palm oil. The palm oil is intended to be used for the food purpose. But I can say here that Indonesia produces a lot of huge amount of the palm oil. We produce about 48 million ton palm oil per year. We just only use in the national need. This is only 25% of it. Yeah, the 75% of it is exported as it is. So it's exported as CPO and its derivatives, of course. So for the food for Indonesia, it's already finished, because it's just need 25% of the Indonesian CPO production. So it means that we have the huge opportunity to replace the fuel importation by the palm oil-based biofuel. Especially now when the Europe start to ban the Indonesian CPO. Yeah, so President Joko Widodo said that if Europe cannot accept our CPO, then we can use it by ourselves. So that's, I think, one of the solution to absorb the large excess of Indonesia CPO production. I think now only the energy sector that can control the Indonesia CPO prices, since the food sectors only absorb only 18 until 25 of the Indonesia CPO production. That's my additional information for my presentation.
Thank you very much, Dr. Makarti Harta. Very interesting presentation. Now, the next speaker is Dr. Dhani Pujianto. He holds MSc and PhD degree in Power System Engineering in 1999 and 2003 from the University of Manchester Institute of Science and Technology. His research works is in the area of power system modeling and optimization, power system economics, regulation, strategic planning and system operation, system security, renewable integrations, many, integrated multi-engineering system, and smart technology evaluation. He is a senior member of IEEE, a member of IET, and the editorial board of Renewable Energy Journal. He is currently a research fellow in Imperial College London. He will deliver his presentation entitled Integration of Renewable Energy Sources and System Flexibility. To Dr. Pujianto, we invite you to deliver your presentation. I think you have 20 minutes, but you can give more. Please, Dr. Dhani.
Thank you very much, Mr. Moderator, and good morning, everyone. Let me try to share my screen. Can you see my screen now?
Yes, yes.
That's
very clear.
Yeah. Okay, so I would like to start with thank you very much for having me in this conference. I will take this opportunity to share some of the thoughts and, of course, the findings from the studies that we carried out at Imperial College London related to the integration of renewable energy sources and also the need for system flexibility. Of course, the studies that we perform normally are on the UK case studies or on the European system, but I would actually will be delighted to, if possible, to have a collaboration with the institution in Indonesia to also to study the Indonesian the energy system. So this is the outline of my presentation. So we will cover quite a lot of bases here. First, I will start with the question why we need to have a renewable system and how much does it cost, the historical and future trends in the renewable energy. But of course, we also need to understand that there are hidden costs of renewables. This includes, for example, the impact of renewables on the system implication of renewables on the generation capacity portfolio, what are the capacity value of these renewables, and also the need for the other infrastructures like the network, storage, and so on. I also will then introduce the system integration cost concept of renewables, understanding those, and then one of the quite hot topic in Europe and also in the UK is actually also to improve the system flexibility in the future, which can then mitigate some of the negative impact of having renewables in the system. There are some cases, real pilot project in the UK that show also the use of smart technologies to reduce the integration cost of renewables. for example, the use of dynamic lighting technologies and so on. I also talk a bit on the market framework to facilitate integration of renewables and the roadmap for flexibility. At the end, I will provide a summary and also some references. So first, we start with the question of why we need renewables. And of course, one of the clear answers is that it is sustainable. It provides clean energy to reduce greenhouse gases and, of course, it mitigate the global warming. It's also has an ability to exist constantly and mitigate the depletion of natural resources. As the previous speaker already mentioned, that Indonesia right now is import quite a lot of energy, and it is because of the depletion of the local natural resources in Indonesia. The second is that it's of course it simulates innovation and technological advancement. We have seen many renewable technologies developed in the past 20 years, from wind, solar, wave, tidal, and even very futuristic idea, for example, like the space-based solar. So you can put a large solar array in the outer space and transfer the energy to the Earth. And also technologies that support renewables, such as smart grid technologies, storage, and continue, further. So many innovation there. It's not only also the in the technology, but also later on in the how to do the business with that. The third, which is now quite clear, which wasn't the case in the past, for example, in 10 years ago, for example, that the cost of the renewable is now quite competitive. But I will come back to this in the next slide. However, on the other hand, there are many concerns about the renewables. For example, and I think the main concern is that how about the security? What happens if the wind doesn't blow, or if it is cloudy? If we, can we meet our peak demand? What are the supporting infrastructure for these renewables? Renewables may be located quite far from the demand center. So we may need electricity networks. We may need to have storage. This has to be included in the cost of the renewables. And of course, the renewables is a variable. This is not dispatchable. It depends on the weather. It also creates complex operation. The standard of planning and operation of the system will need to change because of this large share of the renewables. For example, in the UK, there are a number of standards that has to be adapted to facilitate the integration of renewables. Markets also need to change. Electricity market need to adapt. New services may need to be created in order to help the system to operate with a large share of renewables. Then, of course, it depends also, or maybe driven by the government policies that can facilitate the growth of renewables energy. Now, renewables are capital intensive. It means that you need to pay upfront, while of course the operating cost is very low, but it is quite capital intensive. And because it is a new technology, then there is a significant degree of investment risk. And this will reflect on the financing cost of the renewables. So in this case, that it may discourage the investment in renewables. How about the skill, knowledge? Do we have enough skill and knowledge about this renewable energy? How to operate the system with renewables? And of course, there are other alternatives such as nuclear, CCS. It is the carbon capture and storage using the fossil fuel, for example, but we capture the carbon and store it on the ground, under the ground. This is the levelized cost of electricity from different renewable technologies compiled by this International Renewable Energy Agency based on the actual projects. So we can see a number of technologies like bioenergy, geothermal, hydro, solar, photovoltaic, concentrating solar power, offshore wind, onshore wind. The shaded area here is kind of the range of the fossil fuel cost range. It's around kind of 5 cents to 15 cents US dollar per kilowatt hour. And we can see that what interesting that the technologies that the cost has dropped significantly only in 8 years are solar photovoltaics from 37 cents dropped to only 8.5 cents now. And now it becomes quite at the parity with the traditional costs. Concentrating solar power also reduced from 34 cents to 18.5 cents. Offshore wind now, especially the offshore wind from almost 16 cents to 12 cents. And actually in 2020, the current auction in the UK, the cost already dropped to 4 cents kind of per kilowatt hour. So it is kind of at the lower range of the cost, which is then very, very competitive against the traditional power plant. And of course, the onshore wind. And this cost reduction is expected to continue in future. I got this is just a expectation that it may drop further, for example, for the offshore wind to go to only 3 cents per kilowatt hour, and even the solar, it can be dropped to only 2 cents per kilowatt hour. So it is very, very, very attractive also in the context of the economy. This is a historical trend in renewable energy. So only by 16 years, you can see that from almost zero, to 2,000 terawatt hour per year across the globe. This is supplying 1/3 of the electricity demand. And the future trends, it will increase. That you can see in here that the electricity generation, especially from wind, onshore wind, both onshore and offshore wind, and also the PV, solar PV, and it will increase to almost to 86%, while the traditional conventional supply from the fossil fuel base will continue to drop. This will require a significant investment in the capacity of the solar I think this is a global prediction. It's about 8.6 terawatt, and also for the solar PV, and 6 terawatt for wind. So massive investment in the renewables, and of course this hopefully will promote job creation and a business. Now, there are some concerns regarding the hidden cost of renewables, especially that do we need to have a backup for renewables, because the renewables depends on whether there is energy available at that particular time. So the backup capacity may be needed. That has to be put into the cost of the renewables. It also increases the balancing requirement in the system due to the intermittency and the variable characteristic of the renewables. And then this will increase the system operation costs. It also needs some network infrastructures to transport these renewables, especially from the wind located quite remotely in the area. it's maybe a different compared to the solar PV, which is more local supply. And the fourth one, which maybe not quite understood, is that because the renewables is variables, of course, it cannot provide low carbon energy at all time. And in the system with a very low stringent carbon target, then that's an issue. And we may need to have some additional storage to enable low carbon supply, and this also increase the cost. So this all up for us actually is part of the system integration cost of the renewable that can be defined as the additional cost that ensure these variable resources are of equivalent value to the system as baseload resources. So when we compare different technologies, like the green technologies, for example, like renewables and nuclear, we cannot compare only based on the levelized cost of electricity, but we have to include this system integration cost. And this is the concept of what we call the whole system cost of the generation. And this actually should capture all the concern that we have, the additional cost to provide this security, supporting infrastructure, and so on. So this slide shows the capacity value of wind, for example, just to give an illustration. So what is the capacity value of wind? If we install 1 gigawatt of wind, how much traditional power generation that we can displace with wind? So the approach are a number of approaches, but mainly they try to find what is the capacity of the conventional generation that can be displaced by wind without reducing the generation reliability to meet the peak demand. And this one, for example, the graph, the first graph on the left, it shows on the y-axis is the displaced capacity of the traditional power generation, and the x-axis is the wind capacity. And the curve here shows that how much displaced capacity can be for different wind capacity for different LOLP. LOLP is the loss of load probability. This indicates the probability of not having enough supply during the peak demand. So if we have a stringent security standard, for example, with the 0.05, then the capacity value of wind will be lower. So let's put an example here with the 0.1 LOLP. So with the 30 gigawatt of wind, we can only displace 6 gigawatt of, for example, the normal gas-fired plant, the CCGT. So it means that the capacity created of wind in this case is 20%. So the graph here shows the capacity created of wind for different penetration or for different install capacity of wind. And we can see that the graph show that it reduces with the increased wind capacity in the system, and it will kind of saturate. But this depends on the number of factors. For example, like the wind capacity factors, the profiles, the diversity of the wind, correlation between the low wind period and the peak demand, availability of other flexibility technologies, for example, like storage. So this has to be carried out specifically to the specific system. So, for example, we carried out a study with the wind capacity created for the UK, for example, which largely based on also, of course, the thermal system will be different compared to the wind capacity value in New Zealand, which have a lot of hydro. So this is quite system specific and has to be quantified in its system differently. Now also that there is a concern about how about if there is no wind for quite a long period of time during the peak demand period. So the study here showed that the capacity credit of wind, depending also of course on the no wind days. So if we have no wind days, then the capacity credit is 20%. But if there's one with a very low wind days, especially during the peak demand in the UK during winter season, for example, then the capacity credit drop to 12%. If it is 5 days, then it goes to drop to maybe 2-3%. It's almost nothing. It means that the wind provides the energy, but not the capacity, and therefore there is a need to build a backup plant. But this backup plant will run with the low load factors, and when the thermal station like this, they have to run at the minimum stable generation, which then provide the energy which is not required, and it may prevent other renewables to be connected to the system. So this is part of the integration cost of wind. But also, of course, this also increased the concern about the system resilience with the weather. It is a high risk for the system with the high wind penetration, and as we saw earlier, that for example, like in the UK, that in 2050 it is expected that more than 80% of the energy will be supplied through wind. So having no wind for a prolonged period is a major concern here. A similar approach for the PV. Can PV contribute to the supply security during peak demand? And this depends on the correlation between the peak demand and the solar PV output. So just to give you an illustration here, that this is the demand in the UK for different seasons. So this is got the peak demand, and this is the demand during winter, spring, summer, and the summer peak. And this is the PV production. And of course, during the winter, it's very low PV production, and in summer is large PV productions. But the peak demand in the UK at the winter normally happens around 6-7 p.m. in the evening, where there is no solar. I mean, PV is already, there's no sun after sunset. Is about 4 or 5 o'clock in the afternoon. So it means that the capacity value of PV in the UK is zero. But of course, there is a potential significant capacity in the southern EU, in tropical countries, and it depends on when the peak demands actually occur. There are also some mitigation measures. For example, if we can shift the demand, so it is actually try to follow the output of renewables. This can also help. And mixing solar and wind is also may increase the capacity value of the combined technologies. In this slide, to show that, of course, the geographical spatial characteristics of the distributed energy resources need to be considered as well. In Europe, that wind is stronger in the north part of the Europe, and solar is stronger in the south. And they are normally, for wind, is connected at the perimeter, for example, in the North Sea. This is the study with one of the European projects investigating the transmission, the pan-European grid transmission capacity needed for a different future energy scenario. So if we use business as usual, means that there is a very low renewable energy in Europe, that this graph show the transfer capability between different member states in Europe, and the color show the strength of the interconnection capacity. So in here is largely about 2 to 5 gigawatt connected system. So it's currently like at this moment. And if we choose to have carbon capture and storage, to decarbonize the electric system in future, and carbon capture and storage is dispatchable, controllable, so it doesn't actually drive a significant reinforcement of the European system. There is but of course, in the scenario, there are some renewables generation, and this drive a bit of a network reinforcement needed. Desertec is the idea of importing solar power from the Middle East, and this will trigger a significant increase in the transmission grid. And HIRES, with the higher renewables, it's a very significant reinforcement of the grid needed. You can see that, for example, between Spain and France, this will require about 30 gigawatt of interconnection capacity, while the current capacity is around 5. But the interconnections actually help the system to allocate the renewables at the most resourceful places, and if we allocate the renewables at the best places, then this is the study that we carried out for the European Commission. It shows that if Europe think as a European, it's not only a member-centric, means that, for example, put a lot of wind capacity in the north and the solar in the south, then there will be significant saving in the investment. So it can save about 146 gigawatt of new capacity. For example, like in here in the UK, we have got a 16 gigawatt of solar PV installed in the past 10 years. But this solar PV run with a capacity factor of 10%, where if we install the same capacity in Italy, that will have maybe twice energy productions. So it is important, but this can only be facilitated if there's a strong grid. This slide shows the balancing challenge of having renewables, especially that this is the graphic of the demand. Sorry, the blue one is the graphic of the demand for 7 days, and this is the solar production, and the red one is the wind production, and the purple one is the net demand. And you can see that for the system application is that it will have a shorter peak. The net demand will be peaky. It can also drop to close to zero power compared to that. This is the minimum demand here. So the system will be struggling to cope with this. And of course, during the morning, for example, when the demand increase, but at the same time there is a reduction in the wind productions. So it means that it's actually increased the ramping of the demand that need to be dealt with by the thermal power station, like the dispatchable generation. So this creates quite a significant challenge for the system to operate the system with HIRES. The impact of renewables also increase the operating reserve and the frequency response requirements. So the way that we carried out the study is that we identify that this is the probabilistic distribution functions of the output variations of the wind for the frequency response. We use a half-an-hour interval and see what is the response requirements to deal with this kind of a 95% percentile of this output variation. And on the other hand, for the operating reserve, we use 4 hours duration, and this is due to it's kind of the time needed for the thermal power station from the standby to be synchronized to the system. And the same thing with the probability distribution functions here for the output variation. And we can see that for the frequency response, for example, that this is the wind capacity and this is the response requirement in the system. If we do not have any wind, then the system response requirements in the UK is about 1,000 megawatt, but with and it increased with the increased wind capacity. So with the wind capacity 50, that the response requirement here will be around 2,400 megawatts. So increase more than 2.5 times. And of course, this has to be provided by the dispatchable generation, like a thermal power station or the pump hydro in the UK. And of course, this trigger or incur additional cost to the system. The reserve, because of the duration is longer, it means that the forecast can be larger, the forecast error can be larger, then the operating reserve needed will be significantly higher. For example, in the UK with the zero wind capacity, the reserve is maybe around 2 gigawatts. This is just to cover if the largest kind of loss in feed, which is the nuclear power stations, loss of the nuclear power station is about 2 gigawatt. But with the 50 gigawatt of wind in the system, then the reserve will be needed will be around 14 gigawatt. So very significant increase in the operating reserve requirement. So how to mitigate that? It is recognized, and it is quite a big agenda now in Europe and in the UK in order to enable this to facilitate the integration of renewable in the system. In the future, we need to have more flexibility, and the flexibility in the past is provided, or currently is, they are provided by the large-scale generation or also the large-scale storage system. But in the future, there will be significant flexibility from the demand side, because we have electric vehicles, we have smart appliances. We also have now, there is now a 1 gigawatt of distributed energy storage across the UK. So this flexibility from the demand can shift the demand to follow the wind. So this flexibility will come also from the end user side. So even that if the electricity, the energy still flow from the large scale plant through transmission and distribution through the demand, but the flexibility, some part of the flexibility actually will actually from the end user side. And this will have a significant impact on the system integration cost renewable, as we show here. This is the graph with the system integration cost of renewables compared to the alternative, which is the nuclear plant. So the y-axis here is the cost is pound per megawatt hour. This is in addition to the levelized cost of the renewables. And the x-axis is the penetration of renewables. So, and there are a number of curves here. This show with the maximum progress is that if the flexibility is deployed at the maximum rate, this is the fast progress, moderate progress, and if there is no progress at all, if there is no flexibility from the demand response, to energy storage, and so on. And we can see that with the increased penetration of the offshore wind, for example, if it is from 50%, then the cost will be the system integration cost, if there is no progress, is about 50 pounds per megawatt hour. Just if you remember the earlier slide, that with the offshore wind cost in 2050, it's around 30 or currently it's about 40 pounds per megawatt hour, but that's a levelized cost. The system integration cost is 50, so it means that the whole system cost is 90, which then make it less competitive against other alternative technologies. So and we carried out the same approach to onshore wind, and you can see the similar kind of conclusion can be derived here, that without flexibility, then it will increase the system cost, the system integration cost of the technology, similar to with the solar PV as well. But bear in mind that this is quite a system specific, so the evaluation has to be done on the system basis. Now, we also have carried out studies for the UK government, for example, with for the transition pathways between 2020 to 2050, and this is the carbon emission target. It is the studies in 2016. From 400 gram per CO2 per kilowatt hour to almost zero, is 25 gram CO2 per kilowatt hour. And if we don't have any flexibilities, that the UK need to have quite significant 32 gigawatt of nuclear, from very low in here to 32 gigawatt of nuclear, and also a lot of carbon capture storage needed, and can only have 46 gigawatt of wind, 15 gigawatt of solar, and there is a significant increase in the peaking plant, 81 of the OCGT, because this will be needed if when there's no wind or in the system. But if we have a higher flexibility, then the amount of nuclear drop, I think you cannot see the number here, but it is dropped quite significantly from the 32 to, not mistaken, it's about 19.
Dr. Pujianto?
Yeah.
You have 3 minutes left.
Okay, I will speed up. So the flexibility reduced the need for 19 gigawatt nuclear, 2 gigawatt CCS, facilitate 10 gigawatt more wind by 2050. So it's just to demonstrate how important the flexibility is. So this is the system benefit of flexibility for different cases with the different carbon target, and we can see that with the different carbon target, the benefit increase significantly. And just to put one example here, with the high wind 50 gram, that the system saving is about 7.8 billion. Just to put in the context that in the UK, the whole energy cost is about 25 to 30 billion per year. So it is a quite significant saving in the UK. This is the operational challenge of the in the system with a lot of renewables, that there is a paradigm shift in delivering the security of the supply from the redundancy in the asset in the past to a more intelligent assets. And the source of the control from the transmission to the distribution, because of the lot of distributed energy sources, flexibility at the distribution. But of course, this will require more market regulation that need to be adapted to facilitate that. I will not be able to go through this one, but it's just to give an example of a pilot project in one of the area to implement smart grid technologies to deal with the increased network costs due to the DG and to the renewables. And we say that we carried out a study that, for example, with the traditional network planning approach, with the reinforcing the line, that the capex is 5.1 million. But if you use the smart grid technologies, then the capex reduced to 1.75. This is the use of the dynamic line rating technologies that can help, especially with unlocking the capacity in the system to be used when we have a significant wind in the system. So just to get in touch quite quickly with the two slides. So it is important to have alignment between the market framework with the low carbon agenda. In the UK, it's recognized these four kind of issue that we have discussed before. So in order to ensure the security of the system with the sufficient capacity of the generation, and there is a capacity market here. And also for the balancing resources, we have a number of ancillary service markets from operating reserve, frequency response, ramping capability, reactive power services, demand side response, black start, and also the interaction between the system operators and also the network constraint management. For the network structure, we put the cost reflective just locational and time of use network charges to provide the economic signals for the renewables and also for other technologies. And also that this is a significant shift in the 10 years, in previous 10 years, that because the network infrastructure is a regulated base assets, is a control price, but for the revenue, it includes some incentive and also for the innovation. So if the network is planned more efficiently, that it will be recognized by the regulators to allow the revenue income there. And for firming the low carbon generation, there will be there are contract for difference to ensure to hedge the risk for the investment. Of course, there is a incentive, for example, for the solar power, and of course the emission trading scheme. So it is important to have the market in order to enable this market force to drive the deployment and development of the technologies. And this is the roadmap for the flexibility that in order for that we can move from our not sustainable today's system to a sustainable system in future. We need to have ensure efficient investment decision in providing the increased flexibility services. We need to develop the capability to manage greater complexity in future smart electricity system, ensure innovation support for this improvement in technology and adapting new technologies, for example, and practices in the planning and operational standards. We also need to have a test new operating business model and develop understanding of the customer response to alternative offering by market players to ensure the effective consumer participation. This is a summary of my presentation, that we will have more and more renewables in future. That's quite definite because of the reason it is sustainable, it's already economic, it's also promote innovation and technology. We have to be able to quantify the system integration costs in order to enable this cost-effective integration of the renewable energy, and also to provide the level of playing field which is technology neutral to the market. More complex systems need to be planned and operated. So deployment of smart distributed control technologies will be needed. Flexible assets, coordination between players are important, and also the market need to be developed to facilitate those. It is then my final statement is that it is very important to have a clear energy strategy for deploying renewables and flexibility technologies. So just to quote here that the strategy is about shaping the future. Thank you for listening. Sorry if I'm a bit overrun. And if you have more questions, that of course that you can also contact me in this email. I also put some references for further reading. Thank you.
Thank you very much, Dr. Pujianto. Thank you for a very interesting and comprehensive presentation related the integration of renewable energy. So now we enter the discussion session, question and answer. We have some of the questions submitted in the chat room. I saw Dr. Makarti Harta has answered in the chat room, but it is maybe better to explain it directly here. First questions come from Pak Ahmad Hussain Siregar from USU to Pak Makarti Harta, Pak Dr. Makarti Harta. The question is, biodiesel right now costs only around 5,150 rupiah. How could biofuel from palm oil benefits to the farmers? How could biofuel raise the price of palm oil? Okay, Pak Makarti Harta.
Okay. First of all, the price of the palm oil has to be cheap. It's not expensive. It has to be lowered. It's not raised, because if you raise the price of the palm oil, you help the other country to promote the rapeseed oil, the corn oil, the sunflower oil, right? So You can compete with that. If the CPO price is lower, and then the rapeseed oil, corn oil, sunflower oil cannot compete with the CPO. That's the first thing that you have to think. How to lower the CPO prices is just like this. Now the price of the biofuel derived from the vegetable oil is always more expensive, than the fossil fuel due to the various reasons. Some of them are, first, the price of the raw material is still expensive because the vegetable oil productivity is still relatively low due to the agriculture practices. Fossil fuels are subsidized by the state. That's why the price of the fossil fuel is significantly lower. And then the technology for the producing biofuel is relatively new. That's why the efficiency is still not quite high. There are several ways to lower the price of the biofuel. First, using the most inevitable way is using the inexpensive raw material. Currently available raw material is RBDPO, which is especially prepared for the food. Refined, bleached, deodorized, refined palm oil. Especially prepared for the food. RBDPO is very expensive. That's why the price of the biofuel using RBDPO as a raw material so very high, always higher than the fossil fuel. However, for the energy, the smell and the color of this PO do not need to be removed. For the energy purposes, only gum and heavy metal must be removed. That's why we now, in collaborating with the Ministry of Industry, created the new terminology in the palm oil product, IFO, Industrial Vegetable Oil. This IFO production cost will be much lower than RBDPO. So that's why if the biofuel is produced using the IFO, it will make the price of the biofuel using the IFO as a raw material will be affordable. I hope that's answered your questions.
Thank you very much.
Yeah.
Now, another question, Pak Makartiharta. If diesel power plant using D100, can we call it also renewable energy?
Yes. I answered on the chat room that, but it will be a bit more expensive, since D100 is very high quality diesel. It's intended to be used in the high performance engine. For example, the SETA number of the diesel that is sold in the station is the SETA number is about 48 or 49. The SETA number of D100 is about 75 until it's very high. It's intended to be used in the high performance engines. Since most of the diesel power plant engines are low and medium speed engine, maybe it will be much better if they use the biodiesel or FAME, fatty acid methyl ester. It's not biohydrocarbon diesel, D100.
Okay.
Thank you.
Thank you. Another question from other attendee. How about the development of biofuel of other CPO producing country like Malaysia, Brazil? What technologies or processes they are used? How is the implementation?
Malaysia is also producing the biodiesel. Same as Indonesia. Indonesia produces a lot of biodiesel, FAME, fatty acid methyl ester, but not biohydrocarbon diesel. Malaysia is still planning to develop this kind of technology. Malaysia is collaborating with Neste, a giant of biofuel industries. Is planning to build a biofuel production plant in this country using the Neste technology. Unlikely Indonesia. Indonesia is prefer to use the the merah putih technology to produce the biohydrocarbon fuel. Brazil utilizes sugarcane to produce their biofuels, not CPO, bioethanol, and they have succeeded to implement this biofuel. I think Indonesia have to learn from Brazil how to manage biofuel industries and how to implement it in the society concerning the pricing policy, socio-politics, and so. Now we are working together with Institute of Economic and Community Research, LPMUI, University of Indonesia, currently doing study on the pricing policy and macroeconomic on the biohydrocarbon fuels. I hope this study will also give the kind of contribution on the biohydrocarbon fuel technology production in Indonesia.
Okay. So another question from Budiah Putri Ningrum. Is the merah putih catalyst able to process biodiesel from any vegetable oils other than CPO?
Yes, basically this merah putih catalyst and this process that we develop and design can process all vegetable oil to produce the biohydrocarbon fuel, including used cooking oil. Yeah, used cooking oil is very good raw material to produce this kind of biohydrocarbon fuel, using merah putih catalyst and merah putih technology that we develop and design.
Okay. Another question from Pak Ricky Andrian from PLN UIKL Kalimantan mungkin Pak ya. B100 fail in our engine MAK Bontang. That's why we PLN wanna try D100. Is D100 will admitted by the EBTKE, Direktorat Pak ini, as a renewable energy? If yes, PLN has many diesel power plant, 20 kV idle because there has been grid 150 kV. Silakan Pak.
Yes. My opinion is D100 is a very high quality diesel. As I mentioned before, it's intended for the high performance diesel engine. The Setan index of this D100 diesel is about 70, 75, even 80. So if you want to use the D100 in your engine, in my opinion, you have to mix with the fossil diesel to downgrade this D100, because the Setan number is too high. If it's a Setan number too high, is the rotation of the engine is faster, so the engine will be heated up. That's why you have to downgrade this diesel if you want to use this D100 in the power plant, because the power plant has a low and medium speed engine, I guess. Correct me if I'm wrong.
Thank you very much, Pak Makarti. And next question to Pak Dani, Dr. Dani Pujianto. Question from Pak Ricky Adrian, PLN UIKL Kalimantan. The question is, do you agree that supergrid is an alternative beside batteries, which can avoid the intermittent of PV and wind? Also, it can evacuate big renewable energy to reduce price per cost of system and rise the renewable energy mix of energy.
Supergrid and energy storage, they play different roles. Supergrids normally benefits or from the diversity in the interconnected system. So if you have a diverse use of load, for example, if you connect the Java and Bali and they have different load profiles, then you can share the capacity between the two areas with the grid. if the diversity is low, then the interconnection is not particularly useful in that context. So, but the energy storage, of course, have different. So it is not similar, but we recognize that there are four kind of groups of flexible technologies. One is the network, of course, the interconnections. The second one is the energy storage. Demand response is also quite interesting and quite high in the UK in the agenda, for example, by deploying the smart appliances, EV, and so on. And of course, that the fourth one will be the generation, improving the generation flexibility is also another option.
Okay, another question to Pak Dhani. It's from Pak Ferry from USU. The question is, PV and wind energy sources is intermittent and difficult to predict how the system works to respond to rapid change.
Yeah, that's why I show on my slides that in order to deal with the uncertainty in wind, that the system will require more operating reserve. So this reserve can be provided by the thermal generation, of course, or dispatchable generation, or with the storage. So if you have increased wind penetration, of course, this operating reserve increases, and this will incur additional cost to the system. But the way to mitigate that is that to provide with other flexibility with low cost. For example, with the demand. I mean, the idea here is that, for example, that the demand can follow the wind, because traditionally the power system was designed like for the generation, it's actually follow the demand. So the demand is passive. The demand, if you want to switch on the light, you just switch it on. You do not think about the system. But in future, through the automation technologies that some smart energy system, for example, at home or at building, they will then try to integrate with what system needs. So this is what the future that we are looking towards.
Okay, thank you. Actually, we still have about 7 minutes. Actually, there's no other question, but maybe I have a question for you, Pak Pujianto. It's a classic question. Is it okay?
Yes.
Okay. In your opinion, what key technologies should be mastered by Indonesia to answer the challenge of converting energy from fossil to renewable energy?
And there will be no clear winner, I guess, but a mix of the technologies portfolio will be needed, from the bioenergy, solar, geothermal. Not sure about wind because it is at the tropical country, so wind normally quite low. But maybe there are some areas which you have quite wind resources there. So a portfolio, optimal portfolio of the energy will need to be determined. I think, but this has to be done through specific system studies. So, yeah.
But anyway, how do you think is the right renewable energy to be applied in Indonesia?
Well, I need to say that first you need to do the studies, and this is has to do the balancing between the resources, the infrastructure needed, and also all the system implication and the consequence, like in the previous speaker. For example, with the case with the seaport, study shows that's all the aspects has to be investigated first before we can conclude.
Okay. Another question. What are the main concerns, in your opinion, in developing renewable energy in Indonesia?
Well, I did a presentation about 10 years ago in PLN showing how the Europe moved towards the renewable energy. And the discussion there with colleagues in PLN, they say that at this moment the cost was the main barrier because it was quite expensive during that time. but we see currently that the cost reduces quite significantly. So there may be an opportunity for Indonesia to adopt these new things, but I think we have to be fast, because I think the important is I think the skills and also to understand the integration of this renewable energy is very important.
Thank you very much, Dr. Dhani Pujianto. We still have about 4 minutes, maybe to Dr. Makarti Harta. Pak Makarti, simple question, Pak Makarti.
Yeah.
What is the main obstacle to development of biofuels in Indonesia? What are your hopes of pushing strong biofuel development, especially for you as a researcher? Do you get enough budget, maybe?
Yeah, the funding is okay now. We got the funding from different kind of parties, from the Pertamina, even from the state, from the government, and then from the BPDPKS, from other parties. The funding is okay. The main problem is now maybe the regulation. Yeah, because we are dealing with regulation. We are dealing with the fuels, so there are a lot of regulation that is very tight. It's very, I think it's quite chaotic, the regulation concerning with the fuel. So we need the help from the state. We need help from the government to come up with the idea how to simplify this kind of things, because the idea is we want to disperse the biofuel production units to the oil palm plantation. It's not centralized, but it has to be decentralized. But this one will cut a lot the logistic costs, so it will lowering the price of the fuel, especially the biofuel. But we have problem with we have problem and obstacle with the regulation, and then we are working with it now. I hope it will be resolved soon, but we still have a lot of help from the government for that. Thank you.
Thank you very much, Pak Makarti. We have maybe 2 orally question from Pak Haryadi. Please, Pak Haryadi. Pak Haryadi. Can you hear me, Pak Haryadi? Please send your question orally here, or maybe from Pak Ahmad Perwira.
Or already asked and answered. Pak.
Okay, Pak Ahmad Perwira.
Thank you.
Moderator.
Okay, Pak Haryadi, please.
Okay, thank you very much, moderator. I have a question that I would like to address to Pak Dr. Maherti Kasta. Another question to Pak Dhani. The first question is about the effort to develop biodiesel within the framework of mandatory use of biodiesel, let's say P20 or P30. What do you think about the issues of deforestation? Because based on the study conducted by the SAI, for example, there is a positive relations between the deforestation issue and the rising use of biodiesel. The second question I would like to address to Pak Pujianto. You mentioned on your slide number 4 that cost per kWh on geothermal is rising from the year based on the IRENA study 2008. What do you think about this? The reason lies is on that increase. Thank you very much, Pak Ahmad.
Thank you, Pak Haryadi. Please, Pak Makarti.
Yeah, deforestation. It's not my concern. My concern is the technology to convert the palm oil or other vegetable oil to biofuel. I cannot answer that question. I cannot answer how the deforestation is what's called it happen during the production of the palm oil. Maybe you should answer to another speaker later. I cannot answer that because my concern only how to convert the vegetable oil, the palm oil, and use cooking oil to the biofuel. That's all. Thank you very much.
Pak Dani, please, Pak Dani.
Yeah. So the cost of geothermal, I think this is based on the data, the project cost compiled by the IRENA, and I do not know exactly what the reason why the geothermal cost increases actually, but the geothermal is quite a major technology, and there is now there may be increased concern about the use of the geothermal because of the locations. Normally, it happens in the conserved area, and the cost of the technology may increase slightly. So it is not a significantly increase in the cost of the geothermal, but I just would like to focus on the very significant reduction of the cost of the wind and solar. That's a tremendous reduction in the past 10 years. So we have to take into account on that. Thank you.
Thank you very much. Okay, we already heard presentation and answer from the speaker. Thank you. We have arrived at the end of the session. Pak Dani Pujianto, terima kasih banyak Pak Dani. Very interesting presentation and answer, especially important for a country like Indonesia, which will have started thinking about how to set a strategy, I think, for the mix of fossil energy and renewable energy. Dr. Pujianto also stated that we need to prepare a strategy for deploying renewables and flexibility technology, right? And from Dr. McCarthy, he has explained about the process and catalyst design and development in his lab in ITB, and how palm oil-based biotechnology can be integrated with oil palm plantation. He also conveyed a very interesting national strategic projects on biofuels technology development, where there is collaboration with the Ministry of Research and Innovation, Pupuk Kujang, Pertamina, Pusri, Rekin, BPD, PKS. Okay, thank you very much. Thank you for your attendance and active participation. Back to Dian. Thank you.
Thank you. For all our distinguished speakers, Dr. IGB Ngurah Makerti Harta, Dr. Dani Pujianto, and moderator Dr. Eng Ahmad Korda of Institut Teknologi Bandung on the insightful panel session. And we understand that Dr. Dani right now in London it's very early in the morning, so we really appreciate your attendance and participation in this insightful discussion. For all our speakers and moderator, please stay a moment for a photo-taking session. Our Zoom moderator will take a screenshot. I will count 1, 2, 3. And another 1, 1, 2, 3. Thank you again for the discussion, and thank you again for all our participants and for all the questions that you sent through the link. And before continuing to the next session, we will take a short 15-minute break. And after the break, we will have a keynote lecture with our distinguished speaker, Professor Tatiana Filatova, who already here, from University of Twente, the Netherlands, and moderator Dr. M. Sakti from Universitas Sumatera Utara. But first, again, we will take a short 15-minute break, and we will start the keynote lecture at 11 a.m. Thank you for your kind attention, and looking forward to welcoming you again after the break.
Okay, thank you.
Mah, sekarang sudah ada kontak center PLN 123. Bisa tambah daya. bisa pasang baru. Atau ada gangguan listrik, bisa bagi kontak center PLN 123. Bisa lewat telepon, email, dan Facebook juga bisa nih. Yang paling seru lewat Twitter.
Kalau gitu, Mama bisa ngumpul di sana lebih lama lagi dong. Urusan ke PLN bisa kapan aja kan?
Kontak center PLN 123. Kemudahan akses layanan listrik PLN. Kapan saja, di mana saja.
Kalau dipikirkan, rasa yang tumbuh ini hadir dari kebersamaanku dengannya. Rasa dekat dan peduli ada karena merasa sudah mengenal. Mengenalnya yang baik, dan memberikan keperluan dalam hidup, memberikanku segala keindahan. Bahkan mengenalnya yang sedih dan didera-derasnya perubahan bumi. Dia adalah alam. Aku menaruh kepercayaan kepadanya ketika berada di wilayahnya. Percaya bahwa sekeras apapun dia menerpa, aku yakin semua akan baik pada waktunya jika kita juga menjaganya.
Anak baru, sini. Aku mau nomor kamu now. Maksud saya nomor rekening. Memang kamu nggak mau gajian?
Belum punya.
Bikin dong, now.
Zaman now, buka tabungan, tinggal scan aja. Terus, ikuti langkah-langkah gampangnya. Gak pakai download app, jadi gak boros kuota, apalagi memori.
Nomor HP kamu?
Butuh buka tabungan now.
Saatnya mandiri.
Yes, akhirnya laku juga gue. Pinjam rekening mandiri lu dong. Ada yang mau transfer ke gue nih, penting.
Nah banget. Tuh.
Zaman now, buka tabungan, tinggal scan aja. Terus, ikuti langkah-langkah gampangnya. Gak pakai download app, jadi gak boros kuota, apalagi memori.
Laris manis nih online store-nya.
Kak, boleh kirim foto saya tadi?
Foto?
Butuh buka tabungan now.
Saatnya mandiri.
Yeah, dapat tuh. Tinggal satu bro, harus bayar now. Tapi pakai rekening mandiri, gua adanya cash.
Scan now aja.
Bro, scan now.
Zaman now, buka tabungan, tinggal scan aja. Terus, ikuti langkah-langkah gampangnya. Gak pakai download app, jadi gak boros kuota, apalagi memori.
Helm lu kok beda? Sengaja, beli promo dapat 2.
Butuh buka tabungan now.
Saatnya mandiri.
Daripada handphone kamu hanya diam tergeletak, kamu sudah coba belum menelpon teman lama dan menanyakan kabarnya?
Halo Jaya, lagi pusing soal toko.
Pernah nggak bantu posting dagangan baru teman kamu? Pernah coba belanja untuk mereka yang penting buat kamu? Semoga Hari Merdeka di tahun yang sulit ini bukan hanya jadi slogan semata, tapi jadi titik pengingat untuk saling membantu apa yang kita bisa untuk sesama. Kami akan selalu ada bersama kamu dan handphonemu. Sedikit di sini, sedikit di sana, sebagai satu bangsa, satu Indonesia.
Pagi, masker.
Halo Dr. Sabri.
Halo, di mana ini? Where are you now?
Masih mute.
Oke, hello.
Negeri ini dianugerahi dengan kekayaan alam yang melimpah. Lautan luas merajut ribuan gugusan pulau, membentuk untayan zamrud khatulistiwa. Selat Malaka yang berada di beranda depan Indonesia adalah jalur pelayaran terpenting di dunia. Pelindo 1 hadir sebagai perusahaan pelabuhan utama di Selat Malaka yang merupakan perairan tersibuk di dunia dan menjadi titik penting perdagangan global. Pelindo 1 Indonesia Gateway.
Mau buka rekening tapi mager? Pakai Brimo. Buka rekening langsung dari HP. Login keseruanmu, download Brimo sekarang. Mau gampang login? Pakai Brimo. Bisa fingerprint dan Face ID. Login keseruanmu, download Brimo sekarang. Nggak bawa kartu ATM? Pakai Brimo. Tarik tunai di ATM nggak pakai kartu. Login keseruanmu, download Brimo sekarang. Ribet nginget nomor rekening? Pakai Brimo. Rekening bisa pakai nama alias. Login keseruanmu, download Brimo sekarang.
Kami selalu ada, satukan perbedaan dalam semangat kebangsaan. Kami selalu ada hingga pelosok Nusantara. Hadirkan kemudahan menjadi nyata. Kami selalu ada, wujudkan mimpi. Bagi seluruh anak negeri, kami selalu ada. Dekatkan hati, jadikan jarak tak berarti. Karena kami selalu ada untuk Indonesia.
Terus berinovasi, memberikan kenyamanan dalam setiap perjalanan. Pertamax dengan formula Pertatek untuk memastikan mesin bebas karat. Menjaga mesin agar lebih tahan lama. Pemakaian bahan bakar yang lebih efisien. Karena kami tahu, bagi Anda setiap perjalanan memiliki makna.
Lebih baik Pertamax.
Good afternoon, distinguished speakers, participants, ladies and gentlemen. It is a pleasure to welcome you again to the second day of the Medan International Conference in Energy and Sustainability. Now, without further ado, let's moving forward to our next session. In this keynote lecture, we are honored to have Professor Tatiana Filatova, our speakers from University of Twente, the Netherlands, and as the moderator of this session is Dr. M. Sabri, Head of Mechanical Engineering Department, Universitas Sumatera Utara. Allow me to share Dr. Sabri bio. Dr. M. Sabri was born in Aceh in 1933, and he received his undergraduate degree from Universitas Sumatera Utara in Mechanical Engineering, and master's degree from Institut Teknologi Bandung in Aeronautical Engineering. In 2012, he received his doctorate degree from University Kebangsaan Malaysia in Mechanics and Materials, Computational and Experimental Mechanics. Dr. Sabri is a lecturer in Mechanical Engineering, Universitas Sumatera Utara, Indonesia. Dr. M. Sabri, the floor is yours.
Okay, thank you, Dian. Yeah. So, Guten Morgen, Prof. Tatiana Filatova. So, are you already there? Huh? Okay, still mood.
Yes, I'm here. Good morning to you as well.
Good morning, and so I'm glad and welcome for you to come in. That is a full morning in Netherlands right now, maybe 5 o'clock like that. Yeah. Okay. The honorable all speakers and distinguished guests, ladies and gentlemen. First of all, I would like to welcome you all to this prestigious seminar about energy and COVID-19 held by the Committee of Defense. And this time, we will say that before the presentation begins, allow me to introduce the presenter today. That is Prof. So Prof. Tatiana Filatova. She is come from University of Twente, Faculty of Behavior Management and Social Science, Department of Governance and Technology for Sustainable Development in Netherlands. The education background since 2005 until 2009, received a PhD in environmental economic agent-based modeling from University of Twente, the Netherlands, and then did this. They have a long experience in the professional presence, yeah, and also that many honor and awards, yeah, based since 2001 until 2019. So, okay. Without further ado, I would like to welcome the presenter to present topic today, and the floor is yours, Prof. Tatiana.
Yes. Thank you, Dr. Sabri, and good morning, everybody. And thank you for the invitation. It's a pleasure to be here. And I would like to, first of all, congratulate ITB with this honorable anniversary, and the conference organizers, of course, and especially Mr. Zaid, the chairman, for organizing, and the whole team that worked to organize this event in these peculiar circumstances, of course. And let me try to share my screen with you to so I think I'll try to do it this way. Just a second. Do you see my screen?
Yes, yeah, we have seen already.
Sorry?
Yeah, this is. We have already seen your screen now.
Okay. Okay. Do you see the screen, the full presentation, the full screen, or the one with the notes?
Full screen.
Yes. Yes. All right. So indeed, and indeed, thank you for the introduction. And indeed, today I'm speaking on behalf of myself, but also on behalf of the resilience program that I'm leading in the Netherlands. We work indeed across different sectors, and energy is a very prominent sector. And of course, what I would like to discuss today is well, you spoke about a lot of aspects already. I have seen the program, and there is amazing coverage of topics. So I would like to really focus on the climate resilience and discuss what energy sector can do in face of different shocks. Of course. For centuries, so what is our biggest challenge ahead? I guess for centuries we have been trying to answer this question, and we still do that today in the 21st century. So every year world leaders meet in Davos to discuss the 5 top threatening risks that our societies throughout the world face. And these risks change from anywhere from disease to financial crisis to security, and etc. In 2020, for the first time, all 5 top risks were related to environmental problems. 4 out of these 5 risks are related to climate change, not only in terms of probabilities, but also in terms of impact that it creates. Importantly, these impacts, so the adverse impacts of climate change vary. So just in the past year alone, we have seen a lot of different hazards hit the world, starting from cyclones to heavy rainfall to bushfires and heat waves. These impacts are very different, but they have one thing in common. They become more frequent and more severe than in the living memory of the people. And that makes it, of course, very worrisome. We enter in a way the era of the new normal, and probably most of you have seen this famous warming stripes of Professor Hawkins that illustrate how our temperature globally has changed in the past 170 years. The blue stripes, of course, show cooler temperatures, and the red ones on the right, warmer. And importantly, it's not only about the average temperature increase, but we also know that with the increase of temperature, we are also shifting the tails of this distribution, meaning that we experience more extremes that become less predictable. It all happens, of course, at the very same time when throughout the world, societies are going through the stage of a very rapid development where cities are growing and we're investing heavily in infrastructure, in physical infrastructure, housing, electricity networks, roads, etc., that are going to stay there for decades and probably 100 of years or so. So we're sort of locking our development paths into a particular pathway, which will be very difficult to alter later on. So our today's choices really shape our future risks in that sense. And of course, when we will discuss this problem of development in such a volatile world, it's very important to indeed keep in mind that we have this infrastructure lock-ins with path dependence, like with respect to energy sector. Again, it's about what type of electricity generation are we talking about, how it's being stored, what type of transmission is there, what type of supply chains, and what type of capacity, knowledge, and expertise do we have on board. It's also about handling these uncertainties of the new normal, actually taking decisions that are very long-term without having the full information. Implies that we have to keep the flexibility for an agile response, for the probably to some extent decentralized response to disruption as well. That leads us to the entire paradigm shift in this decision-making when we try to move from just assessing these risks to understanding the resilience of the process. And by resilience, I mean the capacity of the system to develop in the face of shock. So meaning that you need to absorb it, need to learn from it, adapt, and probably self-reorganize, while maintaining the same regime to provide the same functionality of the system. In other words, it's about living with change and building this capacity to deal with it by learning, adapting, and probably even transforming. Of course, resilience is very often discussed as a pathway to sustainable development because it crosses so many sustainable development goals, and of course is very much related to energy as well. So I would like to also bring attention that in the past several years, various international organizations and governments around the world have paid lots of attention to this. In 2019, the World Bank has issued the Lifelines report that discusses the issue, and especially, of course, in the countries that are developing at a very rapid pace. So again, coming back to this issue so that we are shaping our tomorrow's risks. So the World Bank made an analysis, and they assessed that each dollar of investments in resilient infrastructure rather than non-resilient actually delivers us $4 of benefits. So it's fourfold a return on investments that you receive if you invest in a resilient infrastructure. That went in line with the development of the international standards on building resilience of organizations, so of businesses, also businesses that run major infrastructure. Banks throughout the world also have organized in multiple efforts, but this recent McKinsey report also shows to what extent the whole insurance and the banking industry have started to be concerned about this, because of course these are long-term investments and they influence the financial sector. And there are all sorts of resilience discussions about managing these resilience portfolios with respect to climate risks coming around. If we look also in terms of all these economic assessments and the potential climate risks to infrastructure, a lot of this, as this graph from The Economist shows, is actually going into oil and gas and utilities sectors, meaning that this is the percentage of damage that these sectors are likely to experience with climate change, and that's important to account for. Well, the concept of resilience, of course, has been developed already for decades, and and I won't go into history, but I would like to just bring your attention to so-called 7 principles of resilience, and I think they apply very well also to the energy sector. The first and probably one of the most important ones is that people argue that we need to actually build in the redundancy in every system if we want to make it resilient and diversity. So it also means that it's not only about efficiency, so minimizing costs or maximizing outputs, but it's actually consciously building in the backup options with elements of a system that will offer the response diversity, meaning that if there is a shock, different elements, different backup options would actually respond differently. That happens very often with the different type of electricity generation, for example. And the functional redundancy, meaning that there would be possibly several elements of the system that would actually deliver the same function, but would operate differently, responding differently to the shocks. So it's really the less focus on maximizing efficiency, given the volatilities and necessity to build up the backups. The second one is that we need to manage connectivity. And the first step here is really to map it, to understand what are the connections, because of course, the connectivity helps to facilitate recovery if there is something happening in face of adversity, but it also can amplify disturbances, as we, for example, see in smart grids with cybersecurity and etc. But understanding where connectivity helps and where it actually hinders the functionality of the system will help us optimize these patterns. The third and important point is that we need to identify the feedbacks. Identify them. To manage the slow variables and feedbacks. So we need to try to understand what is the environment in which we operate in terms of legislation, regulations, and governance, and try to understand what are the long-term investment pathways and whether the investments that we're doing today are actually strengthening the desired regime or not. And the fourth principle is really about understanding that the system is a complex adaptive system and that there is a path dependency for our investments that have long-term consequences. It's really also about participatory scenario planning and understanding that there are specific critical thresholds after which, for example, it becomes just simply more efficient, even more profitable to invest in one particular energy source rather than another if we take this longer term horizon into account. The fifth principle is to encourage learning. So it's impossible to have 100% certainty on any of the scenarios these days. So we really have to embrace this uncertainty. But it helps to share the knowledge across scales, to monitor it, of course, and create knowledge networks and communities of practice throughout the system. So there are two more principles which I would just like to unite because I think they are maybe less. I won't discuss them that much today. So it's really about broadening participation and polycentric institution, meaning that in in these transitions also to climate resilience and low carbon energy sector, it's really impossible to do that without engaging different stakeholders that are important, different organizations. It's very difficult to do it from the view of one organization or the government alone. So it's really about shared responsibility, shared capacity building, and this nested modular governance. So, and I would like to, in what follows, I would like to talk you through a number of examples, and I see I probably have some only a few minutes left, but I'll try to go through it still. So, of course, the first point which I would like to discuss is about the supply side of the energy sector. Of course, it's we have a lot of elements here. It's about generation, transmission, but also distribution networks before it's being delivered to the users. Electricity, for example, is being delivered to the users. On each of this stage, actually, we could experience different climate-related and extreme weather-related events that could provide disruptions to the infrastructure. That brings us back to the point that if we make these investments that are very long-term and that they are locking us into a particular pathway, we have to account for those disruptions as well. And I would like to show you some examples actually of the work done by Dr. Kamia Handayani, so who is also a participant at the conference. You might know her, of course. So Kamia, during her PhD, she did a very interesting part of the work where she actually tried to understand what would be the vulnerabilities of the power sector in Indonesia related to those extreme events that would change with the changing climate. And the work consisted of two parts. There was, first of all, there was a field work trying to understand what is actually to map. So what have different actors throughout the supply chain, electricity supply chain experience in terms of climate-related disruptances, and what does it imply, and try to quantify it, right? So, and Kamia has collected actually quite a lot of data on financial losses and energy not supplied, in terms of energy not supplied and financial losses related to these disruptances. But that was, of course, part of the work, but also another one is try to understand what are the decentralized adaptation actions that different utilities are taking so far. And to what extent they help. So, and we did it actually in terms of throughout the electricity generation, transmission and distribution networks. And in this article, there is more, of course, about this, but shortly. So it's really about trying to identify the top weather-related events that influence a particular type of the supply chain, electricity supply chain, trying to understand how much actually losses a particular disruptants have brought up, and what type of adaptation actions have been taken up by a particular utility. So it was very important, and of course this was also done for the stage of transmission and distribution. So, and here I only present the selection, but in fact this was quite a unique work in the sense that people do discuss this, but there is very little concrete evidence, and this is where she has provided it in a very structured way. And and we have also listed the number of impacts, how we see that at least impacting the Java-Bali electricity system so far, and the number of adaptation measures that have been taken already on the generation, transmission and distribution networks. So that coming back to the 7 resilience principles, I think it's very important because it corresponds to trying to understand where are this, where do we actually have to build the redundancies, where these connectivities, of course, for example, with the transmission networks matter. And with these bottom-up measures taken up by different utilities, it could be really very important to share these experiences and to see what works where for what type of plants and what type of climate effects. The second step was, of course, is try to understand, okay, so if we know that these vulnerabilities are present, but at the same time, of course, there are quite ambitious electrification goals still, and Indonesia as a country is also responsible, well, has committed to cut emissions. So how does this all come together? So that was the second stage of the analysis that we did. So, and in this case, we already started to use the simulation model, the LEAP model, and actually tried to understand what would be the nexus of this mitigation, adaptation, and electrification goals. So with respect to climate change mitigation, we took the new renewable energy targets, and with respect to adaptation, we actually relied on this field work and an additional literature review to try to understand what would be the climate impacts for Indonesia, to translate those into the effects that we have found in the field work. This said, I would like to note that in this study, we have only looked at the generation and excluded the transmission and distribution network in this first stage of analysis. But what happens, so if we would like just to see what happens, of course, so if we try to start with the reference scenario, which only shows the electrification goals, of course, what you would see is that, and if you look at the future electricity mix for Indonesia, for at least Java Bali electricity system, power system, so then the electricity mix would be predominantly coal-based, but from the field work, we actually found out that quite a few of those power plants might be impacted by all sorts of extremes. So, but before going to that, so of course, what Kamia has done as well is that she ran a scenario with the mitigation goals, trying to understand, so what would this electricity mix look like with the minimum investments possible with optimization scenario, if we can consider mitigation goals as well. Of course, what you would see is that there is a much more mixed set of sources, electricity generation sources, that it would be considerable. But at the same time, if you consider those climate-related impacts, and we did this for two different climate scenarios, representative concentration pathways, sort of the middle one and the most extreme. And what you see is that there would be changes because we would have to compensate for the climate change induced declines in the power generation capacities, and there will be also climate induced surge in the electricity demand. So you would really have to adapt the constraints for the model as well. And what you see, of course, is that in different scenarios, wind or solar would become more desirable. And there would be a trade-off also between the low carbon electricity sources. So that would, of course, also impact a lot the costs of electricity production in these future scenarios. So, and as you would see, so of course, this is the reference scenario that's quite clear. So we here we have the climate change mitigation scenario, the one meeting the targets as the benchmark. But what you see is if you actually would account for the climate-related impacts on the electricity sector, you would have to account for more costs and more capacity, and that we can, of course, discuss. There are a lot of uncertainties, of course, in this particular study. Just a second. So I would like to mention that there are, of course, limitations, but it's quite clear in any case that it will be above the mitigation only scenario. That brings us back to this necessity of actually in each town we would like to have planning for the electricity sector. So we would it's actually quite important not only to account for what happens on the supply side and the demand side and different elements throughout the supply chain, but also in terms of least cost planning model, but also to account for the resilient assessment and planning in this, as also advised, for example, by USAID and many other organizations. So it's really important to account for this trade-off between the optimization and the resiliency planning in the system. And coming back again to the 7 principles in this work, so it was actually reflected, of course, in the diversity and redundancy, but also trying to understand how do we manage this long-term investments in the pathways that create the environment, and what are the feedbacks and what are the feedbacks between the system elements here. So I would like to further bring you into the just a brief in course in the what we have done this time, not in Indonesia but in Europe, because of course if we talk also about building up the redundancy in the system and also making it maybe more resilient in the sense that if one making it modular, then engaging different stakeholders, also users in terms of prosumers, creating prosumers in the system is very important. So here we looked into the demand side and trying to understand what does it mean to make, how does it contribute to the whole notion of resilience. And of course, so we looked here at the residential energy use, which actually contributes almost a quarter of greenhouse gas emissions worldwide. So it a bit varies across countries, but it remains at about this rate. So, and what we did consider here is the role of the households and actually behavioral climate change mitigation. So what could households do on their own in terms of minimizing their CO2 footprint? So this was the work of another PhD student, Dr. Leila Niamir. And we looked into the 3 types of decisions that households can make by themselves and that could be included in the electricity planning. And we looked at all sorts of investments that households do in terms of, let's say, house insulation or installing solar panels. The second type of decision was about really conserving energy, so changing your habits, let's say putting your thermostat a bit lower in during cold days, or not switching on your air conditioning on hot days, and about switching from gray electricity to green. So what we did in this project is that we actually looked very carefully at how these decisions are being made. Of course, we looked into the economic costs and etc. But we also looked at the psychology of behavioral change and used different theories, trying to actually model the entire process in terms of knowledge activation, to motivation, and to consideration where actually the decisions are made, and identify various factors that contribute to the decision at different stages. So we have run a household survey in 2 countries and developed an agent-based model about this. And I would like to just show you one slide about what agent-based modeling is, just in case some of you probably not familiar. So it's really about it's actually a simulation model where we are able to put a lot of social science aspects of decision making. Let's say we could also have all sorts of environmental data and spatial data as we do in any other model, but we also could put in those individual decision makers on a grid. Let's say it could also be non-spatial, but in our case it was spatial, and code in the decision steps in the model. And then if you create, I don't know, hundreds, thousands, millions of these individuals, you sort of create an artificial society in which you could simulate what happens if people behave like this or like that. It's also often done with organizations, not only households. So we did that. So we ran the survey. We tried to identify the behavioral factors. We ran the survey to get the data about this, and we code that in the model. And so we did it for 9 types of decisions in each of this group: investment, conservation, and switching. So we did take these patterns from the survey and put them in the model. And if we do that, then what happens is that we actually can quantify the region, for example, in this case, in the case of this graph, regional effects of behavioral change on CO2 emissions. And what we know is that, I won't go into the details here, but the only thing which I would like to highlight is that, for example, in this case, if we run such policy as price policy, like pricing the carbon emissions, then we would deal with the current behavioral patterns. We would only achieve about 30% reduction in CO2 emissions. If we go to pure information policy, trying to convince people about the benefits of it and etc., we will only receive about 9% of reduction. But if we run the price policy and the information policy together, the effect is non-linear, and we actually are able to cut emissions more than half in this case, because these behavioral factors with economic factors amplify each other and more people are willing to switch. But that's about, of course, regional effects, but very often it's not about just one small region that we need to decide about, but the entire, let's say, economy. And in this case, what we did, we further linked this regional agent-based model with where let's say we wanted to zoom here only in the investment decisions. And from our survey, what we actually found out that people do take investment decisions, let's say such decisions like insulate your house or install solar panels, not only because on the income, actually income was irrelevant for these households in Spain and the Netherlands, but they would do this decision because these decisions are quite profitable in 3 and 5 years. So it's a very profitable investment for a household as well. But whether they would take it or not would depend very much on their age and education, in fact. So even for investment decisions, it's not the income that predefines the take-up of solar panels, let's say. So, so we did take the survey patterns, coded them in the regional model, agent-based model, and connected that with the traditional macroeconomic model that is able to trace them cross-sectoral effects of this change. And what we are able to do then is to map how different European regions would go through these transitions, given the behavioral patterns we would find in the surveys, and a scaling up procedure that we took up in terms of scaling them up. And the important conclusion from this is that actually, because it's age and education groups, and we have the demographic scenarios as well on how different regions would change in terms of age and education over time, we see that some regions actually would benefit twice from these transitions, while others would could lag behind. And coming back again to this resilience principles, and I'm almost at the end of the presentation, I see it's half an hour already. So I would like to just show that it's also very important to broaden participation, because households could contribute, and they could contribute significantly, and you could quantify now how much would it be at the scale of the entire sector. It's also very important to bring in together this demand and supply sides, because, for example, if we just look at one example of heat waves, and again in this latest McKinsey report on the resilience, climate resilient investments, they actually look, let's say, for example, at the annual share of effective outdoor hours that is going to be impacted by heat waves. And apparently Indonesia is actually quite at the top in terms of how much it would be impacted by heat waves. At the same time, energy sector is also going to be impacted by heat waves a lot in terms of the damage to infrastructure as well. So it's very important to demand is growing at the same time as supply is dropping in the heat wave case. So it's very important to match these two sides together. And this is my last slide. And of course, a lot of speakers, I think, have reflected on this, on the impacts of COVID on the energy sector. I just would like to bring in the attention to this, in particular to this Asia Development Bank report that went about exactly this topic. And there is a lot written on this about this right now, because it was quite shocking to realize for many people that even though the economies across the world have been more or less stagnated for several months, the greenhouse gas emissions, according to the International Energy Agency, fall only 8%. So given all the economic hardships and loss of life and etc., this is all what we could achieve by really cutting these emissions. So it means that really we have to make a very, it's not really just about changing what we do alone, but it's really about this low carbon, but also climate resilient infrastructure investments. And the recovery paths across the world are being discussed, and there a lot of attention, of course, is paid at the green recovery and possible transformational change, meaning that you really have to put the entire system. And for the sector like energy, it's really impossible without impacting the infrastructure decisions. On the good side, sorry, this is apparently my last slide. On the good side is that there is a lot of scientific methods on how to do that, how to actually integrate resilience assessment in all sorts of energy modeling. And on the practice side, there are a lot of guidelines being developed right now to help practitioners to integrate this resilience planning in the energy sector specifically, with all sorts of tools and guidelines available. With this, I would like to finish and to, of course, give thanks also to the team with whom I worked, and in particular to Kamia, who is also, in fact, our 40U Resilience Fellow right now. Thank you very much.
Okay, thank you very much, Prof. Tatiana Filatova. So your presentation is related to the energy and climate resilience. It is, I think, that is the important thing now for us in the world to give attention to the climate also, through the energy grow up of the effect of the pollution. And now we will come to the question session. So now I have some question in my note now. So the first question comes from Tulus Burhanuddin Sitorus, that is from University Sumatra Utara. The question is, what are your opinions and recommendations regarding the La Nina hurricane that will affect the energy sector and the economy of several countries to the world? So that is the question from Toulouse. And then please, Prof. Tatiana, maybe you can give the response.
So thank you. So I understood that the question is about how the energy sector would be impacted by adverse events, right? So so as I mentioned, so it's indeed very important to account for this, because we just don't have the luxury not to account for it anymore. And whether we like it or not, the extremes would intensify. They already intensify, also in terms of both in terms of probabilities and in terms of the force with which they come, and not to account for them in planning such an important and vital key infrastructure, right, like the power system at all its stages, generation, transmission, distribution networks, would be would cost us, and it's so it's very important to account for this. And as I mentioned, so I think it's really going back to this different resilience, to this, for example, 7 resilience principle is very important in trying to understand how do we want to design the system as a whole. And very often it's been considered that we really need to have elements of the systems that will be to some extent probably redundant, but and probably would cost us more, but really have these backup options, because we are to experience the shocks, different type of shocks coming from extremes, and this is unavoidable. And it's the uncertainty is really about where they come and how or when, but it's not. But it's quite certain that they will do throughout the world. So it's very important to account for that.
Okay, thank you, Prof. And the second question from Yusuf Islam Kemiring. The question is how to evade the possible mismanagement in resilience as aforementioned. It's the example of connectivity in smart grid resulting cybersecurity vulnerability. Would there be other high impact even that are not in our attention? So that is the question.
Yes, so yes, thank you for the question. Yes, connectivity is a very tricky one, right? It's a tricky aspect of it. So of course we, because whenever, if we experience, if there is a disruptance in the system, then being connected and being able to pick up another component as a backup is very, very important. At the same time, there are the other side of this medal is that also shocks could propagate throughout the system quicker if particular components are connected. But the good news maybe is that when we talk about these two sides of connectivity, we actually very often talk about two different types of infrastructures. Let's say one is about physical infrastructure and information flows and etc., which do not necessarily even have to go through the, of course, they are most effective if they are computerized, but at the same time, there are other different means to assure that information flows. But it's very important to have the physical infrastructure in place as well. With the side of connectivity that might hit back isn't indeed related primarily so far, at least what I am aware of, there could be other examples, is connected to cybersecurity of smart grids. What is being discussed a lot in Europe, at least, is that, of course, especially with the more distributed you are, the more the connectivity is delegated to IT systems, and then these IT systems could be under threat. So this is, of course, important to account for. And I'm not an IT and cybersecurity person to advise how you could manage this. But at least what I'm aware is that there is a lot of research on this going on already, and there are solutions. But it's important to map it for each particular system, and especially for such a key infrastructure, such a key system as the power sector.
Okay. Thank you, Prof. Tatiana. And another question comes from Rina Anissa. So the question is impact from COVID-19 pandemic already reduced 8% GHG. Is there any new strategy for climate change mitigation of the pandemic that can be applied in general? Please, Prof. Tatiana.
Yes, thank you. Whether there is, so the question is whether the COVID has actually uncovered a new strategy for climate mitigation, right? So I think from my personal opinion, maybe what COVID has shown us in terms of difficulty of these sustainability transitions is that first of all, how little emission, how few emissions were actually cut compared to the stagnation of economic activity. So we always think that it's all about the economy, right? So, and etc. So now our economies throughout the world are stagnated more or less for multiple months everywhere. And still, as humanity, we were able to achieve only, well, for different, according to different assessments, anywhere between 7 to 8% of greenhouse gas emissions. This is so minor. So it just uncovers, really, this is only this top of the iceberg, but it uncovers the difficulty of the problem. The second thing which the COVID pandemic has also demonstrated us is how difficult it is to change something structurally in the system, but at the same time that it's really, if it really hits us, we have no choice. Simply, like with COVID, we have no choice but, of course, to take all the measures that nations are taking and individuals are taking. I guess the two biggest lessons from pandemic for climate mitigation is really that it's very difficult, and it's really about changing the rules of the system. We cannot probably really move to low carbon future as throughout the world unless we change the rules. And it's very difficult. So,
yeah. Okay. So I think there is a question come to my laptop, and then maybe when all the participants have the oral question, so please you can ask anything that you want to Prof. Tatiana Filatova.
yeah, I think I see one question from Ariadi. So the question is,
from Ariadi.
Yeah, with regard to 7 principles of resilience you go through the study, to what extent do those principles applicable to upper developing nations, say Indonesia, considering unconsolidated democracy governance? What principles should be prioritized? Thank you. Thank you for this very important question. I think also, so these 7 principles, I think maybe a bit the background, were actually developed primarily in the socio-ecological systems community. So it's the community that has been studying the collapse of ecosystems throughout the world. Many of these collapses actually did occur in the past, but currently they are occurring actually not in the, let's say, global north, but also in the global south. So I think all of them, these 7 principles serve the purpose of sort of mapping what you should be thinking about if you want to achieve the resilient state. But I could, of course, agree that they would differ. Probably some principles will become more important for one system and in one context and others in the other. I think for Indonesia in particular, not but for energy sector in general, and for Indonesia in particular, I think really maybe the first 4 were the most important, and that's why I sort of kept referring to them throughout the examples. Really building in the redundancy, understanding the complexity of this in terms of the path dependency and the feedbacks in the system is very important. Understanding that we really we do that and we try a lot to get more information, but the reality is such that we have to take long-term decisions with long-term consequences without full information. And in that sense, it's very important also not to look only in the past in terms of what worked very well in the past, because the reality of the future is really not going to repeat that. Also in terms of the environmental change that we are going to face in the future would be of a very different extent. So I guess the first 4 principles are really maybe the most important for the electricity sector, for the power sector.
Okay. So thank you for Tatiana Filatova. And when we don't have any question more, so we can go to close this discussion. And also finally, we come to the end of the presentation, and we would like to say thanks again for Prof. Tatiana and for the informative and interesting talk, and to audience for your activity. active participation. Hopefully, the presentation will be beneficial for everybody. Thank you for your attention and good afternoon.
Thank you. Thank you, everyone, and especially the
you.
organizers. Yeah.
Thank you so much, Professor Tatiana Filatova, and also our moderator, who is actually on my right, Dr. M. Sabri, for the informative discussion. So as discussed in that session, my apology, the video was not showing. So as stated in the topic, it's really interesting to discuss about the energy, COVID-19, and the changing world. It is indeed a lot of interesting discussion going on in the first half of the day, but we still have the second half of the event. And we also will have a photo taking session. Dr. M. Sabri and Professor Tatiana, we will take a screenshot by our Zoom moderator. I will do the count. 1, 2, 3. And once again, 1, 2, 3. Again, thank you so much for the engaging discussion, and thank you for the questions. Dear speakers and participants, thank you for joining us at MICES 2020. We will take a break shortly, but please allow us to share this following information first. Number one is we are invited you to please spare a few minutes to fill the feedback form. The link is available on the Zoom chat, which is bit.ly MICES 2020 form feedback. So we really appreciate your input. So we hope that you can spare a few minutes to fill in the feedback form. And the second thing is after the break, we will have the parallel sessions. Please join us again using the link that is already available in the Zoom chat, which is bit.ly Zoom meeting parallel session day 2. Both information and the link are available in the Zoom chat. And the last but not least, we want to shortly inform you, and we also invite the Zoom moderator to please show the break parallel room information on the screen, please. So later in the parallel session, there are 2 ways to join a room. The first one, if you already use the Zoom version of 5.3.1, then you can see in the bottom of your Zoom screen, there are 4 white squares, and then you can choose the room that you want to join. And the second way, if your Zoom version is not 5.3.1 or you're not really familiar with Zoom, you're also able to rename your name. So rename your username to the format that also already available in the Zoom chat. So your name and then followed by room number, and then name followed by institution and then room number. We will give this information again after the break. And so before we proceed to the parallel session, we will take a 30-minute break, and we will start again at 12:30. Yes, at 12:30. So thank you, and looking forward to welcome you again after the break.